Hello, welcome to another stream. How about that? Welcome. So today is Monday, and that means today, according to the schedule, we're supposed to have a code review stream. But since Hacktoberfest is over, nobody submitted that many pull requests, so I had to change the schedule a little bit. And what I decided to do today is continue our genetic programming experiments that we started on the last week Friday. So we already did 2 episodes of genetic programming, and they were extremely interesting. You can check out the source code of the thing that we were developing here. Also, you can check out the playlist of the previous episodes that we had. They uploaded on YouTube. So check them out to get up to speed with what we're doing. And let's just get into it, I suppose. Let's just get into it. Hello everyone. Hello Kolumbetka and Kost, Nibada, Ketison, Zhiyang, Tsoding. Hello me guy, John. Do we have anyone else? That's it. That's streamer, by the way. Hello STD Pau. Welcome. Really glad to see you all today, boys and girls. Sen12, welcome. Metikos, hello. Kiss, hello, welcome. Alright, so for those who doesn't know, genetic programming is basically a technique for optimization. Right, so essentially you take your solution that you're trying to optimize and you encode it as a string. And what you do, you treat that string as a chromosome. And you essentially emulate a natural selection, right? So you generate a bunch of random solutions, a bunch of random chromosomes. You calculate their cost function, or rather fittest function, and then you pick up the one who's the most successful, the one who's the most fittest, and you slice their chromosomes in half, and you cross over them. And thus you create a new generation. On top of that, you also want to apply random mutations on the characters of the chromosome. Characters are called genes, by the way. So that is essential for not being stuck in a local optimum. So random, like stochastic events, like stochastic mutations, help you sometimes to get out of the local optimum and maybe find a better solution. So essentially, you are emulating a natural selection. Right. So, and what is our idea for this project? So we wanted to write a simple game where some sort of agents are trying to survive in an environment, fighting for food and with each other. So the behavior of a single agent is described with a Turing machine style state machine that we call a chromosome, right? So essentially we have a string of rows where we have the current state of the agent, what the agent sees right now, what's going to be the action that is going to happen in that particular state when the agent sees something, and what state it has to switch to afterwards. So when we have like a string of these sort of chromosomes that describe the behavior of the agent, and the idea was to use genetic algorithm to find an optimal behavior that survives the longest. Right. So we also have different kinds of entities. Right, we have first of all agents. We have food and we have walls. Right, food is meant to be eaten by the agents to actually let them survive longer. Wall is an impenetrable obstacle, and all of that is happening actually in a rectangular grid. This is, by the way, a screenshot. A screenshot of the game. Like, I just generated as many entities as possible in a very small space, and it turned out to be a pretty good logo for the project, don't you think? So I really like how it looks like, so I decided to use that as a logo. Yeah, and also agents have different actions that they can perform in the environment. They can basically stay, do nothing. They can step forward. They can turn left, turn right. So they have 4 directions they can look at. They can attack. They can eat, and that's pretty much it. An intentional rhyme, by the way. So, and all of that I wanted to document at some point, so I just put like some sort of like placeholders here, but in the future we're gonna have all of that documented. Yeah, so we already implemented the game simulation, right? So we have game simulation and visualization. So the only thing we need to implement is the genetic algorithm itself. So I really recommend to check out this repo. So I'm trying to document as much as possible. So yeah, well, let's actually fetch those changes because I think I did a little bit of documentation of the screen because it's not that interesting. And the things that I documented, I explained on the stream anyway. So merge origin master. All right. So hope everything I said makes sense. So by the way, we're using C, so pure C. Everything is written in pure C. The only dependencies we use is SDL and SDLGFX, just for graphics, and pretty much nothing else. Well, except maybe libc, because I mean, you need to use libc to interact with the operating system. How are we going to interact with the operating system? Using syscalls? It's not portable. Okay, it's not portable. So this is how all of that looks like. Yeah, red triangles are the agents, green circles are the foot, and we're supposed to have walls somewhere. So here's the wall. It's an impenetrable wall. So yeah, by pressing space, you can actually step like a single simulation. As you can see, some of them made some steps. Some of them moving, some of them doing some things, but majority of them are staying, and this is because their chromosomes are PEPEGA. So after some time, they're all gonna die, by the way, because they're gonna run out of hunger. But look at that. Some of them survived. And the reason why some of them survived is because they managed to eat something. And this is basically the instances that we have to use for the further generations at some point, but we don't have that algorithm yet. But yeah, it's kind of funny when you generate like a random genes, majority of the instances are going to be just pretty much useless. So you're going to have like a few of them that you want to breed further. And what's funny is that we're just using like a random chromosomes. We literally just use a rand function to generate a random chromosome. And they don't really perform really well. And I think this is because our rules are too complicated. Our rules are too complicated because we have separate actions for eating and separate actions for attacking. And I think that kind of complicates the entire system. So I think what we need to do instead, we need to get rid of those actions. We need to get rid of these actions and basically make eating basically going forward towards the food and attacking going forward towards the agent. Right, I think it should be a little bit more simple, so it's a little bit easier to generate actually working chromosomes, right? So we have this kind of steps, or this kind of actions: eat, attack, and of course, if you're trying to eat an agent, it's not going to work because you have to attack it first, and as you can see, it's too complicated. I think if we could get rid of these two actions, I think it would be way easier to work with, and the random chromosomes would actually produce more interesting results. And this is going to be our first step. We already have some to-dos that I planned for today, and one of them is actually simplifying the rules and getting rid of some of the actions that are kind of redundant if you think about it. So let's actually find those to-dos. So yeah, introduce action that menu. Okay, so yeah, we need to simplify the rules of the game. Remove actions. Actions make moving towards the agent and attack. Remove eat action, make moving towards food and eat, and so on and so forth. Yeah, so this is going to be our first step. After that, the next step is going to be introducing an action, a user action, not the agent action, the action that the user can do in the interface, that manually generates a new generation. So essentially, it will take the agents that survived the longest, cross over their genes, mutate them, and then create a new generation and start a new run. So we're going to actually like run this algorithm step by step manually first, just to get the gist of how all of that works. And once all of that done, we can try to automate that and actually try to calculate all of that offline without user interaction, and then we'll be able to look at the final results of the algorithm. So does it make sense? Sounds like a plan. Sounds like a feasible plan for today. What do you guys think? So yeah, yeah, that's pretty much it. All right, cool. Let's get started. Let's get started. So maybe I'm gonna start by creating a branch, right? Because we'll already have some sort of like a well-defined issues. Simplify rules. So we're simplifying rules. So I'm gonna go to the place where we have rules defined. Here they are. And I'm gonna simply go ahead and remove these two actions and just go through the compilation errors. So right now, effectively, we have 4 actions. Nothing, step, turn left, and turn right. Let's just build the entire thing and see how it's gonna go. Alright, so action as sister, so this is needed for rendering. So let's remove that. What's next? Okay, so action it. So we need to move that logic to step, right? So what we need to do here, we basically need to sequentially check what kind of stuff do we see in front of ourselves, right? So if we see the food in front of ourselves, we have to try to eat that food. So, and of course we need to remove that that eat here. If we see something else, it's kind of interesting. So we found the food, and can I do break to break out of this branch and not continue anything else? That would be actually pretty cool, but I think it would complicate things. It would be better to have something like else if, but unfortunately with else if, I want to be able to define a variable like that, and it doesn't really allow me to do that. So I think I'm gonna try to go with the break. So basically break here and it will break out of the branch. It's kind of like unconventional way of doing this kind of thing, but I think it's gonna work for our case. Alright, the next thing, agent, other agent, agent in front of agents. So what we're doing here, we're just checking if there is any agent in front of us, right? Agent index. There we go. And if we do have something, other agent not equal null, right, we're going to try to attack that agent, and this is essentially how we do all of that. Right, we're attacking that agent. Oh, we already have that logic here. Okay, so, and that also gets rid of the attack, so let's not forget this to do. This to do is quite important. A boom. So, and the next thing we want to do probably is to check whether we have the wall, right? So after that, by the way, we have to do break. We have to do break, and maybe I can do something like this: wall, in front. Jesus fucking Christ! Wall of C. So this is game agent index, right? And if wall equal null, if we don't see any wall here, what we have to do, we have to step it. So its logic is slightly different actually. If we don't have a wall, we have to step. But yeah, I'd really like to replace these breaks with a chain of if else, but I have no idea how to do that. Can I define foo and instantly assign it or something like that? It would be actually pretty cool to have something like this. Is that a thing I can do? Or at least use a sequential operator? Does anybody know if I can do things like that? Because here's a sequential operator. In the sequential operator, I define a variable and then I instantly like use it and stuff like that. I think it actually, we need to make an experiment because that would be super useful if it is a thing in C. I know that you can do something like that in Go, but you can't do that in C. God damn it. Do I really have to suffer? Do I really have to suffer? Declarations aren't expressions. But the sequential operator is an expression, is it not? Right, so... Because, like, if you have this kind of thing and you have, like... Alright. You need to suffer, I see. Okay. Let's just go ahead and suffer, I suppose. But we can just use break here in that case. We can just use break. Alright, so I think I handled everything. But what if we predefine all of these variables and then just use them later? Wait a second. I want to give it a try. So what if I already have this variable and then I can do something like x equal 5? Will that work? Yes. Just see, man. Let's see. It will work. Okay. And then it says yes. Yeah. Alright, so we can try to do something like that. We can try to do something like that and essentially just predefine all of these variables here. To be fair, why not just find all of these things right away? But I mean, it actually wastes time, right? So it would be better to do it slightly differently. So I'm gonna do it like that. There we go, food not equal, then other agent. What's funny, for the wall, we don't really need the wall itself, right? We just need to check. Hello, Chromosome Drift, welcome to the stream. Welcome, welcome, welcome. So essentially, yeah, I can do null here, then null here, and I can get rid of these breaks now by essentially doing else and just joining all of that. But I mean, it takes a little bit of space. The lines are too long, but maybe, yeah, because I don't really like that break because it kind of like messes with my brain. And the flow, the control flow is a little bit more obvious when you do it like that, but at the same time it's kind of scuffed. So, alright, so let's go back. Let's go back. Let's actually try to find all of that and just keep it like that. Whoa. So it's going to be else. This one is going to be else. There we go. So more or less okay, I think. More or less okay. Let's continue with the, and of course break. We should remove the break. So if we have a food in front of us, we eat the food. If we have other agent in front of us, we attack the agent. If we don't have a wall in front of us, we just step forward. Nothing special. All right, looks good to me. So let's rebuild everything. Let's rebuild everything, and that's it. That actually apparently it. Didn't have to do anything special. That was actually too easy. Too fucking easy, mate. Why is it so easy? Okay, so let's actually try to run it. Did I create such a good code that changing the rules is so easy there? Alright, so now we're stepping, and I suppose since, yeah. Oh, you know what's funny? You know what's funny? They actually, after eating the food, they don't step. Which is kind of sad, but this time more things survived. You know what I would like to change here? I would like to also step after they've eaten the food. Right, so something like this. Let's also step here. So we've eaten the food. We increase the hunger, and we just stepped forward, replacing the food. All right, so. Let's actually wait a little bit. Let's see until more of them die. And yeah, so we have some of them that survived. I wonder for how long they're gonna survive. Not for that long, but yeah. I like how some of them just rotate forever. Right, because you know, the chromosomes that control their behavior, they are randomly generated. So that's why sometimes you may get a spinning voice. You saw one of them stepping in the food. We can actually reduce the size of the board so it makes it a little bit more obvious what is going on. So I think it's somewhere in the game. So let's actually do something like 2020, and let's reduce the amount of agents. We have 2,000 of the agents. Jesus Christ! Let's put like 10 of them and 10 foods. All right. So. Huh. For some reason that one stopped. I don't know why. Yeah, some of them just spinning around without doing anything. You really need like... Some of them ate the food, as you can see. And yeah, this one survived the longest, and this is probably the one that we're gonna use to generate the next generation. Hello, Ziconfig, welcome to the stream. Welcome, welcome, welcome. But yeah, so you really need to generate like several thousands of them to actually get some interesting behaviors like that actually work. Like if you have like 10 of them, they all Pepega. Yeah, they're definitely all Pepega. That's why I'm generating like 2,000 of them. Alright, so let's actually go back to a lot of them. Hello, Neutral Second, welcome to the stream. And as you can see, like we generated more things here. And at some point, some of them are gonna even survive. That's pretty cool. That's pretty cool. Alright, so let me remove this thing. So I want to take a look at the to-dos that we have. Make agent dropped. We need to simplify the rules of the game. Yeah, that's exactly what I did. I think I, in fact, simplified the rules of the game. That was actually easier than I expected. Remove action it and action attack. With action it and action attack, and we're going to push that right into the repo. Okay, cool. So, and I suppose that issue is done, so I'll have to go to master and merge everything without fast forwarding. There we go. Just remove this branch. So as you can see, now this transaction is over. I don't have a pull, like I don't have a CI to test things out. Maybe I should set up the CI. Yeah, I think I should, in case of somebody will want to contribute something, or also to check my own code on other platforms like macOS and whatnot. That would be actually pretty cool. Because CI is very important, especially in the era of open source, where a lot of people contributing to your project. You need to keep the quality of the source code high, right? And CIs usually help you with that. All right. So let's maybe set up the CI. Contributing animations. You want to contribute animations? That's an interesting idea. Like actually when they rotate, but they rotate smoothly and stuff like that. That's actually not easy, and not an easy task, to be fair, because you need to develop like the whole engine that will do that and stuff like that. All right. So the next issue is going to be introducing the action. Or maybe make agents drop the food when they die. Is that a good idea? Make agents drop food when they die. So, but when do they die? We don't register their death right away, or do we? This is Sokoban level of complexity. Yeah, I suppose. Half eaten food. Alright, let's focus on something more interesting actually. Let's focus on the action that generates a new generation, creates a new generation. I don't want to repeat myself. Creates a new generation based on the best performing agents, right? So introduce an action that manually generates a new generation. Okay, so what we do already in the game. So let's actually find the agent. We already keep track of the agent's lifetime. Lifetime is basically how many steps they made, right? And if they're dead, they're not making any steps anymore. So what we need to do here, we need to grab all of the agents and just sort them in a descending order of their lifetime and pick like 5 the best or something like that and just look at them. Does each step increase the hunger? Yes, it does. Well, I mean, it's hunger, like we have an opposite of a hunger, like it's actually decreasing it, but yeah, so over time, they will need to find some food to eat, otherwise they're gonna die. So that's actually quite important. So what we need to do here is introduce some sort of action. that will give you the best agents somehow. So let's do something like this. Print best best agents. Right. So we're gonna get the game. We're gonna get the game and probably the place where you want to print all of that, just in case. Why not? And maybe how many of them you want to print. Right. Maybe how many you want to print of them. And we essentially gonna call that function when we press N. Right, so this is going to be std out for now, then we'll have to provide the game, and we're going to print like 5 of the best, right? So this is going to be our function. A equal, can someone explain how it works? It actually exploits a comma operator. I would recommend you to check out comma operator in C. Yeah, so thank you, Jian. So the idea is the following, actually, in a comma operator. In a comma operator, you can have even statements, I think. Yeah, you can even have some sort of stuff, right? For example, you have function f, then you put function g, and then 69. And after that, you can do something like this. Right, so this is a valid C code and consequently C++ code. What is going on here? So first the code will call this function, right? So if you have a function f, it will be called first, right? And if it performs any side effects, they will be performed, right? So then it will call function g, right? And it has any side effects, they will be visible. And then it takes the last expression of this sequence and returns it as the value of this entire expression. So we will call f, g, and then we will assign 69 to x. Does it make sense? So essentially, comma operator is the sequential operator. It takes like expressions and execute them sequentially. Then it takes the last expression and makes it the value of that expression the value of the whole sequence. Not sure if it makes sense, but you may try to read more about that on the internet. And this is essentially what I exploit here. Right, so I have a variable, then what I want to do here, I want to assign some sort of value to that variable and instantly check what was that value. Make sense? So yeah, this is what I use here. And since the expression of this entire thing, the value of this entire thing is the value of the last thing, it is equivalent of just this, but with an additional side effect of this first thing. You can also do it like that. Yeah, sure. So thank you, Jiang. Thank you. I think I'm overcomplicating things. I don't know, maybe Go damaged my brain, but Go essentially like allows you to have things like that, I think. I'm not quite sure, but I remember that one of the languages enables you with that, and it's actually quite a useful pattern. But yeah. Alright, cool. Are you gonna give away your hair to charity or grow them long and show them to tourists for $20 worth of ruble? Yes. Alright, so we need to implement this function that prints 5 best engines. Pure Strauss Troop, more like base Strauss Troop. Okay. So print best agents, game CPP. So what I want to do here, I probably want to actually just sort all of them, but I need to allocate like enough memory for all of that. Hi Mikobi, welcome to the stream. Welcome, welcome, welcome. How are you doing? To be fair, I can use the memory of the game itself. Right, I wanted to copy the agents from the game and sort them by their lifetime, but why do I have to do that if I can sort them right inside of the game? Right, so let's actually make printing this entire stuff modify the state of the game, right? So it's gonna modify the state of the game, and what it's gonna do is gonna, you know, sort them by their, you know, lifetime and just pick the 5 ones. So, we're gonna use QSort to do that. QSort. By the way, do I have a man page for QSort? I should. Oh, would you look at that? Wait a second. QSort R. Is that a reversed one? Is it equal to except its comparison function take a third argument? A pointer is based on comparison. I don't think it's a reversed one. God damn it. Anyway, so we need some sort of a comparison function. Right, we need some sort of a comparison function. And we're gonna implement that pretty soon. Compare agents lifetimes. Right, and we're gonna accept const pointer to the agent. Right, so agent, let's call it agent A and agent B. Right, and all that is going to return 0, and we're going to implement that a little bit later. So we're going to assert 0 to do, and we're going to say compare agent lifetimes is not implemented. Is not implemented. There we go. Cool. So what we're trying to sort here, we're trying to sort agents, and how many agents we have right now? We have agents count amount of agents. And what is the size of a single agent? Well, it's the size of agent. There we go. So yeah, since C doesn't have any templates or anything like that, you have to pass as much information about the shape of the data as possible. In C++, in that case, you would derive that shape from the types. Right, so because you can pass type parameters, but in C you cannot pass type parameters, so you have to explicitly pass the sizes of the types. Yeah, but it is what it is. I mean, it's the limitations of the language. And then we're gonna do compare agents lifetimes. So this is gonna be our comparison generic. It's not gonna solve much. You're debating me into the rant again, Jiang. Stop. Underscore generic PTSD. Anyway, so this is how we're gonna sort all of that. All right, do I have to include stdlib? I think I already included stdlib. Yeah, here it is. Epic assert. Yeah, epic assert was pretty epic. Not gonna lie. Not gonna lie. So, and here's an interesting thing. I could have just iterated through 0 to n and just print the corresponding agents to the stream, then game agent I or something like that. But what if n is greater than agent count, right? So I think we're gonna do this kind of switcheroo, right? So we're gonna make it equal. All right. Is it gonna work? It does not even compile properly. Pass an argument for from incompatible pointer type. But do you even care about that? Why do you even care about that? Huh. Do I really have to accept void star and just cast it internally? I thought C is actually pretty liberal in that sense. I mean, oh my god. Come on. Hello GP Brub 0, welcome to the stream. Hello. Host agent, agent A, switcheroonie. Yeah. Yeah, I should be able to do this thing, kind of thing. So we haven't used variables, that's okay. Unused, so what is this one? A known size t. There we go. Is it gonna work? And agent C. Yeah, the function pointer type don't let you cast like that. Okay, so it works for other kind of pointers, but it doesn't work for function pointer. I see. So thank you, Jean. Incompatible type of the print. I think it has to be a pointer. Yeah, it has to be a pointer. It's like this. Oh, I see. Oh yeah, it's a basically a problem of covariance and contravariance. Okay, I see what's going on here. Since you're an epic Java developer, you know what is a covariance, contravariance, and why there's problems with things like that. Yeah. God damn. It's been a long time. No. I'm sorry. I want to be an epic Java developer. Well, yeah, I would not recommend to become a Java developer. Seriously, because first of all, it's not that much of a pleasant work. I mean, depends on who's doing it. For some people, it's actually pretty cool. But the problem is that there's a huge demand on Java developers. So if you work as a Java developer once on a commercial project, it will be super fucking hard to get out of that area, because like every HR is gonna call you to work in Java again. Like everyone, you already have experience in commercial project in Java. Yeah, go work for us, go work for us. They're gonna throw money at you, as much money as possible. And it's gonna be super hard to get away from that, seriously. Yeah, so I'm just sharing my experience for you, so be super careful with that. Once you got a commercial experience with Java, it's gonna be really hard. It's gonna be really fucking hard because a huge money is gonna be at the stake. No, not the money, please. Looks around, nobody's throwing money. I mean, you have to become unemployed first, I suppose. I'm not suggesting that though. Okay, so we need to implement the compare agents lifetimes. So can you pass lambda into the sort? C doesn't support lambdas, unfortunately. It would be cool if it did, actually. It would be pretty cool if it did. In C++ you can pass a lambda that doesn't capture. Wait a second. Is that like a standardized feature? That you can pass a lambda that it's gonna work correctly? So the lambda that doesn't capture will be compiled like as a regular function. Fucking really? Wait a fucking second. No, wait. I wanna fucking try that. Excuse me, that's actually very interesting. No capturing lambda can decay to function pointers, I see. Alright, so we're gonna do main C++. I'm really sorry, but yeah, I wanna check it out. I actually wanna check it out. So we're gonna do cstdio, cstdlib, and I'm gonna just have like a think. Surprise, surprise, C++ is not that bad of a language. Yeah, I see. Well, that's fucking awesome, actually. Yeah, that may make me want to use lambda more. Thank you so much, Jiang, for telling me. Yeah, that's actually super cool. So, and let's actually do something like access size. Exercise. Size of access divided by size of access 0. Right, and we're gonna do qsort. Access. So what was the next one? I forgot. Qsort. Let me copy paste this kind of thing. So the base is going to be access, the amount of elements is going to be access size. Then the size of a single element is size of access 0, and instead of this kind of thing, we're going to do a comparison. I wonder if I can do something like this, A and B. And essentially, the comparison operator is something like this, right? So essentially, if A is less than B, it's going to return a negative value. If they're equal, it's going to be 0. If B is greater than A, it's going to return you like a positive value. I think this is how it's going to work properly, probably. Okay, so what we can do here, we can try to print this entire thing. Exercise. Print F, D, exercise, and after that, of course, we want to print a new line, right? And somewhere here, we want to print something like that. Okay, so let's try to compile this entire thingy. Doesn't compile because why? Invalid use of const void. Oh shit. Okay, so okay, can I do something like this then? So it's gonna be, well, I mean, at least it actually like thrown like a type error that is sort of relevant to what I'm doing here, which is pretty fucking cool, I think. It fucking worked. I mean, it fucking compiles. Alright. For fuck's sake, Jiang. Oh my god. I'm gonna give you VIP. Thank you so much. That is so cool. Alright. Alright. So it's literally like a function. Nice. Thank you so much. That is fucking cool. That is so fucking cool. I love it. Oh, it was your idea. Alright. I'm gonna give you VIP as well, Top Wild. I'm really sorry. I cannot give you the real VIP yet. You've been around not for too long. So I don't really know you that well. But maybe if you stay around for quite some time, maybe at some point you'll get a VIP. But that's actually pretty cool. Yeah. Thank you so much, everyone. I should probably read more about lambdas. Like, I briefly read about them and used them, but never knew much details like that on them. Sinduri Tube Worm. What the hell is that? Thank you so much for a year of tier 1 subscription. Thank you, and welcome to our epic C++ club. How about that? So what is that? Alright. Since it's a... So yeah, it's a like anniversary of your subscription. It's pain. It's pure pain. I do understand you. And that's why we're gonna listen to this song. So this is for you. This is for a year of subscription. My god. Imagine being subscribed for a year. This is for you. Alright, so let's continue. Yeah, but I cannot use lambda, right, because it's a C, so I still have to create a separate function for all of that. Still have to create a separate function. So, and this is kind of similar, I think. So I'll have to do agent A. TGS didn't try to pronounce the link. Yeah, I mean, maybe the text that it sent the link. Somebody sent the link, and it just didn't do that, because there's no point to do that. Okay, so let's take lifetimes. What's interesting is that it's gonna sort them in increasing order. So for a decreasing order, for descending order, I think we have to do something like this. What are you coding now? I'm programming, I'm experimenting with genetic algorithms. You can find more information here. Thank you, 26. And also check out the playlist of the previous parts of this genetic programming experimentation. So it's actually pretty interesting. Yeah. So I suppose this is how we're going to sort them in the reversed order. And that should just work. So, and also we don't print the lifetime. Let me quickly try to print the lifetime. There we go. Let's try to recompile all that. I'm new to stream only CPP. We actually program in all sorts of languages. We program in C, C++, Rust, D, Haskell, sometimes JavaScript. So it actually depends. So I would really recommend you to check out our schedule for different projects. And also check out our organization on GitHub, because we store all of the projects there. Right. So yeah. So we'll also program in assembly from time to time. TypeScript, as you can see. What else do we have? We have Go. We program in Go. D, Elm, but we programmed in Elm a long time ago. Apparently Java. Sure. But yeah, so we program in all sorts of languages. So welcome to our multi-language channel. So mostly low-level languages. How do you define a low-level language? So, what is a low-level language? What is a high-level language? Is there any criteria? All right. So, let's just run the game then. Cool. Yeah, low level, no Python. That's a very interesting criteria of high level and low level. Alright, so we're gonna wait until everyone dies and only several of them survives. Alright, that was a beautiful, beautiful, beautiful song. Thank you so much. Let's continue listening to something else. And maybe JS. But what's the criteria? How do you know that JS is a high-level programming language and something that is not JS is not? Like, what is the criteria? It's so arbitrary. Like, low-level, no GC. But what about Go? In Go, you can even have like segmentation faults. In a high-level language, you can fucking have segmentation faults and it has a GC. What's the criteria? Tell me. Thanks for suffering for me, Mr. Tang. You're welcome. You're welcome. Thank you for joining the stream, Sinduchi Worm. I'm really glad to see you. So, let's wait until all of them die. Okay, some of them died, and we have some of them that didn't die. We're gonna wait a little bit, and we're gonna press N. And N is supposed to print the best of them, right? So it prints the best of them. And as you can see, all of them have a lifetime of 21. But I wonder if we can have, like, see what is the average. Yeah, so they all have hunger like 5 and stuff like that. But these were the best of them. How FP can be a low level? I have a feeling that nobody knows what low level and high level means in this chat. Do you even know what you guys talking about? How do you know what is low level and what is a high level? Low level equals machine code, everything else is high. Well, at least it's some sort of criteria, right? At least it's already better. Python, JavaScript, low, I don't know. Like, whatever you suggest, it's already better than majority of people said so far. So, how can agent with the health 0 be in top 5? Because the performance, the health of the agent is irrelevant to its performance. Alright. So, but what I would also like to print the corresponding chromosomes of the agents. So, I think that will be also pretty cool. But the problem is that chromosomes are not part of the agents, right? The agents are, it's their states, but maybe they should be part of their of the agents. I have not decided yet. Yeah, let's actually make a small switcheroo, super quick, and I'm gonna make chromosomes part of the agents. Maybe it will actually simplify things. So where's the agent definition? So here's the agent, and where do we have a chromosomes? There we go. Chromo. Oh, we have 45 raiders from Kebab Skull. Thank you for the raid, and hello raiders. So we're doing a genetic programming. How about that? check out the project command to learn more about this kind of stuff. And this is the third part of genetic programming, so check out the playlist for the previous part. So yeah, essentially we're just making like a small Hunger Games thingy, where we have like small agents that move around, and their behavior is described with chromosomes. And we're going to use genetic algorithm to breed the fittest agent that can survive the longest in the environment. So that's essentially what we're doing here today. So yeah, and we're coding all of that in C. So yeah, stay tuned if you're interested in this kind of stuff. Maybe levelness of some languages can be determined by the amount of hard-coded built-in abstractions. Maybe. So, and I want to get rid of the chromosomes. So now we only have agents, we only have foods, and we have only walls. How do you measure performance? Essentially for how long the agent lived. So we're optimizing their lifetime. If they lived the longest, that means we're going to use them for the next generation of the genetic algorithm. Yeah, that's going to be the idea. So they have hunger and they have health. They can find food and eat it. And they also can fight with each other, right? So, and having this combination of things that can kill them contribute to how long they may live. So yeah, they have to survive as long as possible. All right, so what do we have here? So we don't have chromosomes here, and so what I have to do here, I think I should extract chromosome from here. Right, it's gonna be like this. And it's gonna be like this. Remove. Why don't Sojing drink tea anymore? Because I don't want to. So why is it that? Why is that important? Why is that important? All right. So this is not a pointer, right? Cool. And then we'll have to find the agent, its chromosome, and then the corresponding genes. And everything seems to work. So now a chromosome, a part of the agents, which is actually pretty cool. Can we print chroma? Yeah, we do have chroma printing, which is quite convenient. So if I go to print agent, I should be able to also print its chromosomes, right? So let's see how it's gonna go. Chroma equal, and I wonder how exactly I'm gonna print that. I think I'm gonna just go with a very stupid idea where I'm gonna just do print chroma, chroma agent chroma, and I think I have to provide the stream. And do I have to provide it as a pointer? I think it would make sense to provide it as a pointer. This thing has to be const, by the way, because when you print something, there's no much sense to modify it, right? So let's actually keep it as const. Let's just keep it as const. All right. So we're gonna let them live for a while. All right, we're gonna leave them, let them live for a while. That very much looks at the cam with the look as if you said something stupid, which might be true. Anyway, very funny. So here we go. So we have agents and we have their corresponding chromosomes. So essentially the chromosome consists of the state of the agent, what it's supposed to see, the action, and what it should switch to. This is actually interesting. If it's in state 4 and it sees agent in front of it, it should turn left and stay in a state 4. Which is quite funny. So basically, when it sees the agent, it should keep rotating and stuff like that. So this is basically the chromosomes, if anyone is interested. So yeah, and these are the best chromosomes that survived, I suppose, that survived for this amount of time. You should start your magnesium level, will thank you later. Best part is when you const misclick incorrect letter. What? Okay. Coffee is a type of tea. Alright. We have pretty controversial topic today. Okay, so let's continue. So what we're working on is next generation. So this is the next generation. Okay. Introduce action to print top 5 agents at the moment. Right, top 5 at the moment. And I'm gonna push that right into the video. Hello, Yatanasa. By the way, hello everyone who just joined. I'm sorry if I missed anyone. Welcome, welcome, welcome. Really glad to see you all today. So, yeah. So we have print the best. And what we need to do here is, I think, we need to... I'm gonna actually make a pretty controversial function. I think you're gonna like it, chat. It's a pretty controversial function. Mate agents. Okay, so it takes 2 agents. Parent 1 and parent 2. Right. You see where I'm going with that. Right. So, and it also gets the child. So, essentially, what this function will do, I know it's kind of monkey-to-OS, but it is a part of the genetic algorithm, okay? It is a part of the genetic algorithm to mate your solutions. You have 2 solutions, right? And you have to mate them into a new solution, right? So, and what this thing will do, it will take half of the chromosomes of the parent 1, half of the chromosomes of the parent 2, and put them into the chromosomes of the child, right? And then we're gonna use this function to generate, to make a new generation of agents. Are there female agents? I don't think like we're gonna actually associate any gender with the agents, because I think gender is not really relevant. What's relevant is we have to take half of the chromosomes from one parent and half of the chromosomes from another parent. Like there's no reason to even have gender here. Right. How it's controversial, I don't understand. Well, because this function is basically makes agents to fuck with each other. Do I really have to explain all of my jokes? Thank you very much. Alright, so let's continue. How are we gonna do all of that? I wonder if... so I think the parent 1 is gonna define the first half of the chromosome, and the parent 2 have to define the lower part of the chromosome. But you're supposed to talk about flowers and bees first. Yeah. You know what? To be able to split chromosomes in half, I think the amount of genes in the chromosome has to be even number, I think. So, and I think we have to enforce that at compile time. So we have genes count, right? So we have some static asserts. Yeah, I think I'm gonna move this static assert closer to the constants, right? Closer to the constants. And I'm gonna just put it here. Okay, so static assert, and what we want to assert here is where the genes count mod 2 equal to 0. Genes amount of genes in the chromosome must be an even number for the mating process to happen properly. Yeah, for mating purposes to happen properly. Yeah, so this is what we're gonna do here. So genes count, it's 10 of them, so that means it should be relatively easy to just do all of that. Does mutation take place in your simulation? It does not, but it will. I just didn't implement it yet, but we're gonna implement it soon. So we're gonna mutate it in a very simple way. So we're gonna have a separate function, which is called mutate agent. So it's gonna take only a single agent, right? And it's gonna basically flip one of the genes of that agents with a low probability, right? I think I want to actually make it a separate function. So when we're gonna do the whole like new generation function, we're gonna have like separate steps: mating the agents, then mutating the child, right? Mating the agents, mutating the child, mating, mutating, mating, mutating. I think it's like it's gonna be a little bit more readable in the end, but this is just me. But yeah. So assert mutate agent to do mutate agent is not implemented. There we go. Mating mutating. All right. So mem cpy, and we're gonna copy child chromo genes, right? So this is the destination from parent1 chromo genes, and how many genes we want to copy? We're gonna copy genes genes count divided by 2. So you see we're copying half of the chromosome of the first parent, right? And then we'll have to copy the second part of the chromosome of the second parent, and I suppose we'll have to do it like that, right? So it has to be plus half of the genes here again. All right. To be fair, I think that's it. That's the whole mating process. Seriously, like we take half of the chromosome of one parent, half of the chromosome of the second parent, and we merge them in the child. That should be it, essentially. But I mean, yeah, we'll probably have to add like half here like that. Yeah, maybe we also want to pre-compute this value, but maybe the compiler will optimize it properly. I don't know, maybe it will optimize it properly. But it would be actually kind of cool to have that for readability, right? Something like length. Yeah, let's call it length. And we're gonna just simply replace it with length everywhere. There we go. I think it's a little bit more readable. Does it make sense? I think it makes sense. Yeah. Thank you so much. Alrighty. So mutating agents. Well, we just have to iterate through all of the genes of an agent, and with a certain probability, right? With a certain probability, we have to generate like a new thing there. What programming language is it? This is C. This is a pure C programming language. So do we want to like regenerate like the whole gene? Maybe it makes sense to try to regenerate the whole gene. So one of the things we can do, actually, we can do rand int range, right? Int range. Do I even have that? Int range random, I suppose. It's a random int range, and it's going to be from 0 to 100. Right, and if it's equal to 0, so it's a 1 in 100 chance for that particular gene to mutate, right? For that particular gene to mutate. And how do we generate this kind of stuff? So I can initialize the game. So I just initialize the game. And this is how I generate new chromosomes here, right? So I might as well actually do it in a similar way. So I'm gonna just regenerate the whole gene from scratch. And that will mutate it. That will mutate it. Size of genes. I have to go. I will follow and watch later. Bye bye. See you around. See you around. Okay. Agents. There we go. And this one is a pointer, of course. This one is a pointer. So essentially, we just generate a new state, we generate a new environment, random action, and so on and so forth. And I think this has to be a probability of the gene, and it has to be like a special command. Mutation probability. Right, but it's not really probability, right? It's I don't know how to like explain what that thing is, right? Let's actually call it prob. So mutation prob, right? So mutation prob. And if it's 100, that means there's 1 in 100 chance. So, and that's why let's call it chance. Yeah, mutation chance. I think it's a pretty good name. So I'm gonna put all of that into here. Right. So here's the mutation chance, and there we go. Yeah, this is how a mutation is going to work. We have a particular mutation chance, and then that mutates the gene. Okay. So this is a single agent. Cool. What I'm thinking about is that, okay, so we have a functions to perform this kind of optimizations and stuff like that, this kind of steps. But how do we generate a new generation? This one is interesting. New generation. So this is going to be the function game.h tournaments. Yeah. Make new generation. So old, new. Let's call it game and new game and new game. So essentially, we're going to have two games, right? We're going to have two games. We're gonna have two games, and I think also old game should be modifiable. What this thing will do, it will find the best agents in the previous game, right? Like best 5 agents of the previous game. Use them to basically mate with each other, right? It will mate them with each other, and then put them into the next game. Right, the next game is probably going to happen in a different environment, but will it happen in a different environment, and should it happen in a different environment? I'm not quite sure. As I remember, you can get n of top survived and then feel left with crossing among all. Okay, so you can actually do different things differently, like, and depending on how you do things, you're gonna produce like different results. So I'm gonna do it like that. I'm gonna just pick the best ones, right, and mate them with each other, right, trying to produce like the best result, and we'll see how it goes. Good idea to give them the second chance. Maybe I'm gonna put it to do, because right now I just want to implement it like as I have it in my head. All right. All right. More different mating strategies, right? So more different mating strategies. All right. Different strategies for next generation. So for next generation, make next generation. So this is how we're gonna call this function. For the same environment, food and all, generate the most fitting for such environment. Okay, so sounds good idea. So that means we're gonna copy the environment from one place to another one. Hello Aguduk, welcome to the stream. We're already mating agents with each other. Look at the signature of this function. Just look at it. Look at it. This is such a funny signature, like a parent 1, parent 2, and the child. And basically, we take half of the chromosome of the parents and put them into the child. So that's what we're doing. We already implemented these functions, by the way. So we're just literally copying them. I have seen lecture of Dave Churchill on Twitch and he studied the subject to students. Well, cool. The thing is, I didn't read anything about genetic algorithms. So my idea is that I have the idea of genetic algorithm and I just want to implement it myself. I just want to discover things myself. I just want to experiment things myself, and I don't want to watch other people talking about it before I implement something myself, because it kind of ruins the fun for me, because I want to sort of explore that. Yeah. So the only thing I know about genetic programming is its description, right? Its description, and I'm going off of that. So sorry for not doing how you're supposed to do things, how you were told. Just like to do things my way. I'm not a programmer, but why we use this pattern of pass return, aka the child as a parameter instead of returning a new child? Passing, well, because it lets you place the child in whatever place in the memory you want. If you return the child, you're doomed to have the child on a stack, but if you don't have it on a stack or in a different place, so it's not particularly convenient, so it's rather better to have like a pointer. Does it make sense? Okay. So for the previous game, we'll have to modify, we'll have to essentially sort the agents first. So there we go, we're sorting the agents. And now we need to have a constant for how many we're gonna take out of the thing. So I think maybe we're gonna call it like selection pool, right, or something like that. I'm not sure if it's a like correct terminology, probably not. Right, selection pool is gonna be 5. So basically, how many of them we pick out of the previous generation, right? So, and it's going to be something like size t, I actually 0. So selection pool, then size t j0, selection pool like that. If I actually, I'm just thinking. So I think the selection pool should be half of all of the agents, right? Maybe it has to be, maybe it's too much actually. Maybe it's too much. So if I'm gonna half of them, the majority of them is gonna still be Pepega. So I'll have to keep doing that until I feel all of the agents, unfortunately. So yeah, let's give it a try. Okay. I think I know what I'm gonna do. I'm gonna do slightly different strategy. Because I need to generate exactly 2,000 of the agents for the next generation. That's what I need to do. I need to generate exactly 2,000 of them, right? And I only select 5 of the best of them, right? So that's the problem. I need to, like, I have 5 of them and I need to generate 2,000 of them. Right. And so essentially what I'm going to do instead, right? What I'm going to do instead is agents count. So I'm going to iterate here, and I'm going to pick a random out of the selection pool, right? So it's going to be something like random int range, and I'm going to just select random out of the selection pool, and so maybe it's going to be P1 and P2. Like I select 2 random out of the selection pool, and this is the ones that we're going to mate here. Does that make sense? Makes sense? Probably makes sense. Okay, cool. Okay, cool. So game.h mate agents. Mate agents. So the parent one is going to be which one? Game, previous game. That moment I'm happy that I'm just a little C# developer who can just not care about memory management and throw all the responsibility on client. Cool. Agents P1, so this is the first parent. So the second one is this one, a previous game agents P2. And we're gonna do next game agents I. So you see what we're doing here? Yeah, previous games, like 2 random parents out of the selection pool, and we add them to the new agents. And on top of that, we want to go ahead and mutate that agent afterwards. So mutate agent, and we just put it like that. Right. There's a small chance of mutation. So here are the 2 steps of all of that. Now, how do we initialize the rest of the stuff? So we do that in the init game. So what's funny is that we only do that for the chromosomes. The next thing we have to do, we have to do this thing. Yeah, we have to do this thing. So we mutated everything, and in the new game, in the next game, we're gonna generate a new agent, like a completely new agent. And then for the foot, speaking of the foot, I suppose I'm gonna copy paste the food. Yeah, I'm gonna simply copy paste the food. So this is the next game, and this is the position from the previous game. Similarly here, I'm gonna do this thing like that. Previous game. Surprisingly enough, I think one of the things I want to do before doing anything else, I want to mem set the whole game to 0. Right, so it's 0 initializes and sort of makes sense. All right, so we have a next generation situation. And we can try to use all of that. Agent has no member genes. Really? Oh, because it's It's a chromosome. Yeah, so I have to do something like chromo dot. Okay, is it gonna work now? Why did I put this thing here? I don't quite know. Alright, so previous game, we're sorting everything. No chroma. When mating agents, don't forget to say no chroma. Funny, is it? Alright. So cool. Now I need to call this function somewhere here. But here's the thing. I need to have two games, right? So I need to have two games: the previous game and the next game. I'm a comedic genius. Yeah, you are. Init game. So this is where I actually want to do memset as well. So it's going to be game 0 size of game, like that. So we're just going here as usual. Until everyone dies, and yeah. Let's go back to here, maybe. Main. Yeah, so we're gonna have games. We're gonna have two of them. All of them are 0 initialized and stuff like that. So, and essentially we're gonna keep track of the current game. So we're gonna call it current. The current one is 0. So essentially we're gonna just flip-flop between them as we generate new things here. And we'll see how it goes. So we're initializing actually the current game. So it's going to be games current. So there we go. So this is what we're initializing there. Games current. And boom. When we step in the game, we step in actually the current game. And when we doing this thing, we're actually reinitializing the current game as well. All right. So it's supposed to be called games. It's supposed to be called games. Okay, so when I'm mating the agents, right? When I'm mating the agents, what am I doing? So I need to have something like next, and the next is essentially 1 minus current. Does anybody recognize this pattern? Does anybody recognize this pattern? So it's actually a pretty useful pattern. If you don't know about it, I really recommend you. Like, because you're competitive programmer, you know what it is. But it's essentially flip-flopping between 0 and 1. So essentially, if current is 0, the result is going to be 1, right? So, and if the current is 1, the result is going to be 0. So basically, this pattern lets you just flip-flop between 0 and 1. It's actually very useful. And this is exactly what we're going to do here. So, and essentially we have a function that makes the next generation, right? And we take the previous game, which is game current, right? Game current, and then we generate the next game. After that, we generated the next generation, so the current is going to be next. There we go. So, isn't it cool? Isn't it cool? I think it's pretty cool. So, yeah. And that lets us to flip-flop between the game areas, right? Without, without too much memory management, right? Yeah, it's actually kind of like a double buffering. It's a very close to double buffering. So, yeah, that's what it is. Since like I'm using C, memory management is kind of like an ass. So what I'm trying to do here is to not use dynamic memory because it makes everything difficult. And I think I was pretty successful at that. I don't have a single malloc here. This is a pure C, and there's no single malloc here. So all of this static memory that is required by the entire thing is here. Here it is. There's nothing else. Like, yeah. So that's the whole buffer that we need. And it just contains everything that we'll ever need. All right, so if I try to recompile that, so this is supposed to be called games, and there we go. So, and when I click on the, okay, so that has to be current. So, and then we render in the game. It's also current. All right. So I think we're ready to try things out. We'll let them live for some time until majority of them die. And I think everyone is dead. So I'm about to press N to generate a new generation, to make a new generation. Okay. Oh shit, okay. Here's an interesting thing. Some of them got generated on the food. And this is because we took the food from the previous step. Okay, so I think it should be super easy to fix. Essentially, before trying to generate the agents, we are copying food and walls, so they take place in the game. So the random empty coordinate on the board will actually give you correct coordinates. I think that should work now. All right, so we'll let them live until some of them die. All right, and we are about to generate a new generation. And as you can see, none of them generated on top of the walls or anything else. And so this is a new generation with the top 5 survived agents. Top 5 survived agents, and also different mutations. So this generation should perform way better. It should be more active. It should try eat the food, and let's see what's gonna happen. And none of them are doing anything. Are they gonna die? The fuck? That's actually really strange. Pepegus just died. Alright. Okay, cool. So what's the... Takes lots of generations. Natural selection and natural, yeah, sure. So I'm kind of like curious, what does it do in terms of the initial state? What's the initial state? So for the agent, initial state seems to be always 0. Initial state seems to be 0. So what if we actually try to increase the size of the chromosomes, and maybe the amount of states as well, so they just start doing something more interesting. Maybe also increase the selection pool. Mutation chance, state count, okay. Genes count, let's actually make it 20. States count. States count. Let's make them 7. I don't really want to make too many states, so maybe 7 is more than enough. Alright, let's give it a try. Okay, they're doing things. They're doing things, hopefully. Some of them maybe even survived. So this is how many survived, we can clearly see them. And then they stopped. We're generating a new generation. Okay, the next one. They're becoming more Pepego and Pepego, to be fair. So they're just staying and doing nothing. Yeah. Alright, so let's actually commit whatever we have here, because we already have some sort of a mating algorithm, do we? Is this good? It's not actually really good, but they're not doing anything. How many agents do you regenerate randomly? I don't regenerate anyone randomly, I just use the top 5. But maybe, yeah. Maybe I'm Pepega too, but what are genes? You mean genes? It's a joke, yes. It's a joke indeed. Alright, so let's actually come into whatever we have here. Because it's actually pretty good. Seduction pools start larger than smaller. Well, we'll see. We'll try to gather some ideas on how to fix that. So, oh, by the way, let me also do this thing. So we introduce generate completely new state of the game. All right. Out9, hello, welcome to the stream. Welcome. How are you doing? Welcome. So, what we're doing right now, we're mating agents. So they're making babies. So it's gonna be N KBD. Make a new generation based on the best performing agents. There we go. So essentially, we have a function called mate agents, right? That take parent 1 and parent 2 and a child. So in essentially what this thing does, it takes half of the chromosome of the parent 1 and half of the chromosome of parent 2 and puts it into the child. So this is basically what we have. And also we have mutation step, and yeah. So right now the strategy is actually pretty dumb. So we're going, we're just generating agents. We pick up random like top parents. And we're mating them and just generating new agents. And it doesn't work, by the way. It doesn't work. We're trying to figure out why. Alright, so let's actually do a committee. And then the problem is that they get one more chromosome that need it. I don't think so, because they... I mean, yeah. The size of the chromosome is actually fixed, right? So, and it's fixed in memory. So it doesn't grow, it doesn't shrink. So it's always the same. It was a joke. I'm sorry. So, I'm actually worried that it's not gonna work out. All right. So introduce an action to make a new generation based. Let's make a new generation, and let me go to the master and actually merge without any fast forwarding. Next generation. There we go. So I don't have any pull requests right now, so I'm sort of emulating pull requests locally. Yeah, I debated you debated me, I see. Alright, let's push the master. So what I want to do right now, I want to make a small break because I need to refill my water, I need to pee, and I also need to think a little bit on how to move forward, because it's kind of interesting why it just doesn't work. Parents do not survive. It is sad. It is sad, but I think it's also important from what state they're starting. Parents are less Pepega. Yeah, for some reason parents are like really less Pepega. I would have thought. Alright. So, let's make a small break, guys and girls. Let's make a small break, and you guys have fun. Welcome back, everyone. So let's continue. What I was thinking about, maybe we do really need to have more generations and stuff like that, maybe like thousands or several thousands. So, and because of that, we probably have to do that in a more, like, less interactive manner, right? So maybe we need to write a program that takes the initial state, right? The initial state of the game, performs like, you know, several thousands of the generation and spits out the resulting state afterwards, right? So, and maybe to facilitate that, we're going to have two separate applications. The first application will perform the training and stuff like that, and the second one is going to perform the simulation and visualization. So yeah, we're going to have two executables. But to actually transfer information between the training application and the visualizing application, we need to be able to dump the state of the game and load it up. So we need to come up with some sort of a format to do all of that. It's kind of interesting. So I think this is what we're gonna work towards. And once we have like a training application that can train for thousands of generations, maybe we can try to troubleshoot that and see how we can make the training faster and stuff like that. Because training manually is actually kind of like tedious. Maybe it doesn't make any sense. What if we want to create the training time lapse in the future? Well, I mean, for that we can have like a separate application. We can have a flag that the training application will just save all of the previous states, and then it will spit out the time lapse for you. I don't understand why that could be a problem, so I don't think it's a problem. So yeah. So first of all, I think we need to be able to dump the state of the game. We need to be able to dump the state of the game. Unfortunately, that format like greatly depends on the values that we have coded in the game itself, right? Because we have such things as what's your micro? Is it some what? What is micro? I don't understand. Excuse me. Basically, we can make an app for everything if we can dump the right data. Yeah, sure. Microphone, I mean. Check out my FAQ. All of the answers are all of the questions are answered in FAQ. Thank you. So yeah, it all greatly depends on the agents, foods, amount of walls, amount of genes, and stuff like that. So, and a file dumped by the application with these parameters is not going to be compatible with other parameters. So maybe all of these things have to become dynamic or somehow. But yeah, we'll see. Food hunger recovery. Yeah, maybe it has to be like, all of that has to be like a part of the game, like part of the state of the game, to actually properly work. That's very interesting. But that's a lot of additional work, but maybe that's exactly what we want to do here. Or maybe we're gonna actually stick, for now at least, with these parameters, and then we can implement something later that, you know, performs better or whatnot. So, alright, let's implement a function called the dump game. Right, so we're gonna provide the game, we don't need to modify the game for sure. Right. So, and we're gonna accept the stream where exactly you want to dump this game. Init game. There we go. So we're dumping the game, and how exactly are we gonna dump the game? Well, we can try to first dump the agents, right? So it's going to be game. So we need to dump the agents. If you want to dump a single agent, we'll have to dump its current position, its directory, hunger. Wait a second, can we just dump a binary there? Just take the game and dump a binary. Like, seriously. F-write. I mean, I think it's gonna be the easiest way to do that. Like, you don't even need any fucking format. Just dump. But the problem here is that you won't be able to read it outside. Right, you won't be able to read it outside, but it's the easiest thing to do in C, right? So the size is this size of the game here, and you want to save a single thing here to the stream. Right, and read, if I remember correctly, it can fail in some particular situations. Does not distinguish, yeah, you have to do like F error of some sort. So if F error stream, okay, could we can crash somebody here. So I'm just thinking maybe it would be better to return the error somehow, indication of an error, right? So you can check whether it failed outside, but I'm not sure if it makes that much sense to do it. Like, yeah, let's actually check it here. If error, we're gonna do printf std fprintf. I mean std error could not save. Oh yeah, and this is why you want to do that outside, because you don't have a file path, right? You only have a stream, right? So that's why you wanna do it like that. Yeah. So it's gonna be return that and just int. Let me take a look at f. Yeah, f right. Thank you. It has to be f right. F error and f error is like this. Cool. Do I have this as a part of the interface of the game itself? Dump. Yeah, there we go. And it has to return integer. It has to return the integer, and we are ready to go. So I'm gonna go to the main, and in the main, I'm gonna have like a key that saves the state somewhere. SDLK, let's call it D for dump. Right, we're gonna take a huge dump and dump everything. So dump the game, and we're gonna just dump the current state of the game. Right. So we're just dumping the current state of the game. Take the huge dump. Alright. So maybe I also am gonna print something. Where we're gonna dump them? So file, dump file, fopen, dump file path. Let's define somewhere. Dump file path. Dump file path, and the file path is gonna be something around like game binary. If this thing is equal to null, we're gonna say could not open the file. Std error could not open as file. Dump file path. Dump file path. So exit 1. After that, I'm dumping this file into here, right? And then if f error. What does f error return? What is the return? Where's the return section? I don't understand. Okay, so I probably have to read about this function then. Test the error pointer, the error indicator we set on the test the error indicator, but it doesn't say what does it return. So maybe I'm blind, but I'm gonna assume that if it returns something, if it's not 0, that means something went wrong. So if that could not dump file, and then we're gonna close this entire thing. So here's a dump file, and I'm gonna do printf dumped. Why do it current state to s dump file path. Dump current state. Alright. So if open to few arguments, we're gonna open it with writing binary. Alright. So and now if I press D, it dumped the current state to the game.bin, and it's actually a pretty big state, as you can see, right? 716 kilobytes, and it contains the current state of the game that you can try to load up. And we can write a simple application that actually you know, does the training for several generations and so on and so forth, and dumps like the resulting thing. So you know what, let's actually write that training thing as part of this application, but in a separate main, and we're gonna switch between them as needed. Does it make sense? Does it make sense? So this one is probably not gonna use any SDL, so it's gonna be purely like offline thingy. Once it's done, we can probably separate them to different binaries. I think it will make sense. So dump game, and another thing I want to have is load game, right? So we're gonna have a string and a pointer to the game, right? There we go. So we need to learn how to load the game, and loading the game should be actually similar to dumping the game, right? It's just instead of write, we have to use fread, right? Simple as that. Simple as that. And essentially, yeah, we just do that. But the problem here is that fread may actually read a different amount of character than the size of the game. So what we have to do here is assert that the amount of characters we read is equal to the size of the game here. And that may happen if we change some of the parameters of the game that we hard-coded and stuff like that. But in the future we're gonna unhard-code them, but for now we're gonna just do these kind of measures. Yeah. Okay, so we have a load the game, and it seems to be working. It seems to be working. So dump file path, I'm gonna actually put it here, right? So we can reuse it in other places. Alrighty. So f open. To be fair, why the fuck am I passing stream there? Why am I passing stream there if I could have just passed the file paths? It kind of doesn't make any sense. Like, and just pass the file paths there because, yeah. Oh my god, I'm such a beggar. Like, it would simplify fucking everything. Like, just put a path there. Yeah. It's gonna be file path. And those functions are going to be responsible for opening the file, closing the file, and do all of this nasty shit for you. Yeah, that makes sense. That makes sense. That makes sense. So let's put them here. So, and we're going to put this thing here. Remove that. Remove that. All right. So f open file path write binary if f equal null, printf std error could not open file. Hello FreeFile, welcome to the stream. Welcome. You're not really too late. We already implemented the like mating strategies and stuff like that, but none of them work, so don't worry about it. You didn't really miss any epic moments when suddenly we had like super computer agents that can like destroy everyone. Yeah, all of them are Pepega. Even after several generations, they actually degrade over several generations. So I don't think they're improving. So we're definitely not doing something right, but we'll see. Okay, so here's the F right, and what we're doing here, we're saving the game into the stream. I should have actually called this thing stream. To real, yeah, it's almost like we're emulating like a real life, right? The generations are degrading. Alright, so, and if this thing have failed, Usually limitations are bad more than good. Well, we don't really know the reason why this thing doesn't work yet. Could not dump to file this, and after that we have to close this file, of course. There's a suggestion: add a role to the Discord server called announcement and basically ping announcement every time you stream. So the people get notified. The person will follow a lot of people on Twitch, so that's lost. Oh, okay. I see. So, and essentially make a bot, right, that assigns these roles when people want to. I think we already have that mechanism in KGBotka. I'll think about that. Thank you so much. I think it's a pretty good suggestion. Announcements role. Yeah. Default Twitch phone notification. Yeah, so essentially how, like, similar to how we did, like, with Potato and PHP role, right? So basically you click to get an announcement role, but yeah. This means all channels accept announcements. Ah, I see. Yeah, I'm using an overlay camera because I think it has, like, a better FPS. I don't know, can you see it's just, like, better FPS than in Player. So yeah, I decided to start using it. Does it look better? I'm not sure. I actually had to slightly decrease the quality of that web camera because it was consuming too much resources on my laptop. So, like, it was running at full HD. Now I think it's 760p, I think. Looks like 30 FPS, yes. So before I think it was less than 30 FPS. So this makes it smoother. I don't know. Alright, so what we're doing... So does it compile? Does it compile? It probably doesn't compile because we have some trash here. Yep, semicolons and shite. Semicolons and shite. Load the game. Another semicolon. I think the gene crossover function is too aggressive. It destroys coherent agent behavior. Cool. Thank you for letting me know. Alright, so we're gonna do a similar thing. File stream, f open, so file path, read binary. Can you still do the pop trick with the overlay? I actually talked about it. So essentially, I want to write an OBS extension or plugin that lets me pause the video capture of the video capture, similar to how we did that with mPlayer. So we're watching party. Well, I'll think about that. I first need to get into the anime, and then we can think about anime watching party. So yeah. So this sounds like a pretty good topic for one of the streams. Extend OBS so you can do the trick with OBS without mPlayer. Yeah. What do you guys think? Yeah, I think it's a pretty cool idea. Because I never actually worked with the internals of OBS, and I think it would be really interesting for me to do that. Alright, if stream... I actually don't mind some sort of like a anime watching party. We just need to think about how to organize that. I don't think you'll even need to use an OBS. You can make a virtual cam, then use in OBS. I don't know. We need to research what would be the best solution for this kind of situation. But I want the solution to be as simple as possible. I want the solution to be just installed and just work. I don't really want to do additional work like creating something outside of OBS, virtual camera, something. It's too Linuxy, right? I want things to just work, right? Kind of miss things working. So str could not open file as. Open file as. So it's going to be exit one, right. A simple solution would be to put a picture of empty chair over camera overlay, but you can also do more tricks than that. You could do more tricks than that in mPlayer. So I don't think it's a sufficient solution, I'm sorry. Alright, so after that, we just read the stream and we check the size of this entire tab. Why don't you use 3D technologies in your projects? Because I already use blockchain in my project and I ran out of buzzwords to use in my project. Yeah. What kind of question is that? Like, Jesus Christ. Alright, so let's continue. Could not load from file path, and we're gonna exit that. So I almost implemented this thing shut. I almost implementing saving and loading the game. What's the 3D technology like? Like it's one dimension better than 2D technology? But everyone knows 2D is better. Alright, so when I dump in this thing, so I can now dump file, dump game, and dump file path, and I have to do something like game current, actually games current, and I can remove all of this scheiße. Okay. Dump game. Oh shit, it compiles, cool. Okay, so we can start implementing the trainer. I don't even know how to call that thing, but the natural selector. 3D neural network. I mean, aren't they already like multidimensional anyway? If you think about that. Okay, so we need to load the game. We're gonna load the game into, we're gonna load it from dump file path, and we're gonna load it into games current 3D multi-layer receptron. Ah, I see what you mean. Okay, that makes sense. Okay, so this is where we're loading this thing. And what we need to do here is we need to perform several generations. So genu I max generations. So for now, we're gonna go with a fixed amount of generations. Right? We're gonna go with a fixed amount of generations, max generations, and let's say we want to have thousands of generations. Benny Darshan, I hope I pronounced your name correctly.
You said blockchain, say had to sub.
That's too easy, but thank you so much for 5 months of tier 1 subscription. Thank you so much for such a continued support, and welcome to our epic blockchain club. That's right. So you see, streaming and easy, you're just screaming buzzwords and people throw money at you. Yeah. Sounds like IT in general, right? Because in the modern IT, what you do, you just scream in buzzwords and people throw money at you. That's how it works. I think that's how it works. All right. So we need a function, actually, chat. We need a function. Is everyone dead? Guess what this function does? is everyone dead? So basically it checks whether everyone is dead or not. And I think that's the time to generate a new generation. Blockchain, neural networks, machine learning, cryptocurrencies, game dev, Zodian use mesh shaders. Yes. I'm gonna use them. I'm gonna use mesh shaders for all of these things. Imagine using mesh shaders for blockchain. That's actually sounds fucking awesome. Mein Gott. Mein Gott. Absolutely fucking awesome. So how are we gonna check that? We're gonna iterate through all of these motherfuckers. Agents count. And if game agents I health is greater than 0, that means nope. Otherwise, yep. Yep, go. Yep, go. Throw nuclear missile at. Huh. Nah, we're gonna implement it later, but thank you for the suggestion. It's when your generation goes to shit. Oh, would you look at that? Something went wrong here. And I didn't really change any parameters. I didn't even change any parameters, but we already have an incorrect game. What the fuck? That's really strange. So, okay. If I try to save this thing differently. Sodium mesh shader HOTS. Sure. Okay, so I dumped some shit again, didn't I? Yeah, I dumped some shit again. So I can go back and just switch to a different thing here, and hopefully it will be able to load it up. Hopefully, we'll see. We'll see if it will be able to load it up, and it doesn't load it up, so it just says that the size of this thing is not equal to the size of the game. And I wonder why. Is it because it cannot read the whole thing at once? So we can try to inspect all of that. So, yeah, probably F3 does not guarantee that you can read all of that at once. So I'm just being Bebega as usual. Just being Bebega as usual. I'm so good used to being Bebega that I don't really care anymore. I feel like I'm not a very successful programmer anyway. Size of game is always 8. But I dereferenced that thing, didn't I? Yeah, so, yeah, don't worry about it. I'm also Bebega. So, yeah. And it read only one character. That's very interesting. And I think I'm the hugest Bebega I've... Yeah, can't read anymore. It's understandable. Don't worry. So, size of a single thing. What if I wrote a thing incorrectly? So this is a write and this is a read. Why did it read only a single thing? Fread. Oh, it returns the amount of things. Oh my god, fread and fwrite interface is so confusing. So fread and fwrite interface, it doesn't work with the raw bytes. It works with elements. And what it returns, it doesn't return you the amount of bytes it read, it returns you the amount of elements it read. And what essentially I said read one element of the size of the game. And of course this mother flipper returned me 1. Jesus Christ, I almost had a heart attack. Oh my god. So because, yeah, it's so scuffed, I mean, it's confusing. Yeah, so here you specify the size of the elements you want to read, and then you specify the amount of elements. And since I have only one game, it makes sense. Okay, so here's the size of the element, and I have one game, read one game. So, and I don't know why for some reason I thought, like, it will return the amount of bytes, but yeah, it is what it is. It is what it is. Cool. Sounds like something Feng Chi would design for his language Uwu. Do we have Feng Chi here today? He's probably sleeping. Yeah. I mean, Feng Chi is a huge fan of C, so maybe C actually influenced. Well, C did influence his language a lot. So, all right. So now, if I try to run this entire thing, right? If I try to run, everything seems to be okie dokie karaoke. So this is where we are starting to do a generational thing. Hello, MMTPL, welcome to the stream. And a huge fan of making scuff design decisions too. Well, I mean, aren't we all? How many scuff design decisions I've made throughout my life? That's actually a lot. Because how do we come up with good designs? Basically, we come up with the first scuff design, and we put it out there, people start using it, and people starting reading at you for a scuff design, and you fix it, right? So I guess that's how we come up with all of that. Because when you're making a design, it's kind of difficult for you to keep the reality check, right? Sometimes, because you're designing in your own world, but you don't really know how it's going to be applicable for other people. So you need to put it out there and wait for people to start reading at you. Iterate your customers. Yeah, that's an interesting idea. Okay, so while not is everyone dead, right. While not everyone is dead, we're gonna step the game. So step game. And we just step in the game. Right. Once everyone is dead, we are making the next generation, like this. Next generation, and continue this entire cycle. And we do like thousands of generations. Right. We do thousands of generations, and afterwards, what I want to do actually, so we have a new generation, and I think what I want to do here is to dump that generation. Dump game, dump file path of the current game. But to be fair, I think it should have like a different name. So dump file path. So let's have something like trained file path. So trained bin. So, and maybe it will also make sense to log what's going on. Generation I, right? And also like this. Okay, so here we go. We're just training things thousands of times. And then we dump the latest generation. The next thing we're going to do afterwards, we're going to switch to our visualization, and we're going to look how that generation performs after all of this training, just to get the gist of all of this thing. All right, so I'm starting the training right now. Generation 0, generation 1. Oh shit, thousands of generations is actually going to be super fucking slow. Is it really? Wait. Do you notice that it's getting longer? Why is it getting longer? Is it getting longer because they're starting to live longer? Wait a fucking second, that's actually very interesting. Think about it. It's kind of getting longer. Okay, so I have an idea. Let's actually make amount of generations like 10. Right. So the first generations, like they take, maybe we can also print the amount of times, like, yeah, amount of time. So GP, it's actually very fucking interesting. So it feels like it's increasing or something. Schrödinger's genetic algorithm, either it's a success or a memory leak. Well, I don't have a single malloc. Right. So src grep rn malloc. So not a single malloc. I don't think I have a memory leak. I also don't have a single calloc. Right. I don't allocate any dynamic memory. So, and that's exactly the reason, by the way, so I don't have to deal with the memory leaks and stuff like that. Right, so I just pre-allocate as much memory as I need, and I just use that memory. It's like my favorite style of development. Because in that case, you almost programming like with a garbage collector, because you don't manage memory, but the reason why you don't manage memory is because you don't have any fucking memory. Anyway, so what I want to do here is clock t begin. Big brain, exactly. GPC, so we have time, printf. Took. So I'm gonna do it like that. I'm gonna also flash std out, and here we're gonna print something like f. So it's gonna be clock minus begin. And I need something like divided by clocks per cycle. Does anybody remember how it's called? Clocks per cycle? Is that what it is? Per sec. Clocks per sec. Okay. So this is a clocks per sec. Yep. And we need to cast it to float and cast that to float as well. And this is S. And there we go. Might as well flash it once again, just in case, because you never know. My chat arena highlighted brain because there is a person called that in this chat. Interesting. Oh, I didn't know that chat arena can do this kind of stuff. Alright. So let's go. Doesn't compile. Please compile. Okay, 2 seconds. It takes longer, what the fuck? Why does it take longer to do this kind of shit? Alright, so the time is really increasing, I think. Not always, but... Processor leak. And it goes like to 5 seconds and just stays. And then it goes down, I see. Maybe they live longer. I don't know. Who knows? I hope they do, but... What does genetic programming do? It optimizes the problem using genetic algorithms. But it's... yeah. Oh shit, it didn't actually damp anything. God damn it. Why didn't it damp anything? Oh, it damped the same thing to itself. God damn it. I wanted it to dump like to trained. Alright, so I wanted it to dump to trained, but I guess that's okay. So then, after the 10 generations, we can take a look at how they look like, and hopefully maybe they will start doing some useful shite. So here, instead of init games, what we need to do is load game. So again, it's going to be games current, and we're loading it from dump file. So that should be it. And then we're going to switch our entry point. So we're switching our entry point. Could you easily calculate the average lifetime in each generation or some other performance measure? Yeah, I think we could. So let's actually see what kind of generation we generated. Let's go. Something went wrong horribly. I didn't understand really what, but I think I fucked up the thing that we generated. That was really strange, but Why did they die? Did they move or something? I don't quite understand what happens. Do they move? One more time. So, okay, something is happening here. I need to keep my eyes close to that. Okay, so some of them, like majority of them who were in front of the food, they moved towards the food. Alright, so what they do, they move in... Okay, so the ones that moved towards the food sort of survived. But if there's no food in front of them, they don't really survive much. So... yeah. But it's actually... I think it's actually working. After 10 generations, we found some of the species that simply have a gene that makes them move towards the food. I think this is already something, is it not? Think about it. By the way, can you see that? Can you see how they move towards the food? Especially the one on the left. Yeah, for example, this one. Look at this one. Like there's like a row of food in front of them, and what they're doing here, they're moving towards the food, and they consumed all of the food, and they're gonna survive the longest. Right, so they survived. So, and there's a lot of them. So what they developed a very simple gene. So that gene is that if you have a food in front of you, you move forward, but unfortunately they don't have a gene to do something else. Right, so we need more generations and stuff. Does anyone know where the food is? Yeah, so there is like a parameter of a gene. If you have like a food in front of you, you can perform a particular action. Right. So they have a little bit of vision. Next, simulate epidemic in the population. I actually wanted to do something like that after I watched 3Blue1 Brown video, like because 3Blue1 Brown did like a video on that, and that'll be actually pretty interesting to do as well. No cannibalism. You know what? Can we make like a simpler, like a smaller thing? Smaller board, smaller amount of entities and stuff like that. Because like right now, 1000 by 1000s, right, so we have 1000 by 1000. Oh, 100 by 100 actually, not that many, but still, we have like thousands of agents. But maybe that's okay. So right now it's actually kind of slow. The whole training process is extremely slow. And this is because we have a lot of like linear algorithms and stuff like that. Can we parallel of that? Probably not. But it will be interesting to leave it like a little bit longer and to see if we can come up with more interesting generations and stuff like that. Alright, anyway, I want to commit what we have. I also would like to like separate these two executables. We really need to separate these two executables. The one that will like train these things and the one that will visualize their behavior and whatnot. So, but I need to think how to do all of that. So, let me think. So see, main. So I think visualization is going to be purely just stepping through. The stepping through. So also we have this thing. I feel like they need more context, like seeing until a wall max to 5 should be good, or for the agent brain. Cool, I'm really glad that you think so. Thank you for sharing your thoughts. I'm really happy to listen other people's thoughts on the topic. Cool. Now let me think. What would be the best way to do that? Because if we're gonna have like a separate executables, we need 2 separate single compilation units, right? 2 separate single compilation units. And that means I'll have to move this entire thing in here, if that makes any sense. I have to move this entire thing here. So let me quickly try to do that. So we'll have to do a little bit of a refactoring. So header, I'm not gonna have any headers right now, so this is gonna be that. Refresh the page, otherwise you're gonna have the delay. I'm really sorry, I really apologize for this. I think it was kind of my fault. So, yeah, I'm really sorry. CIA, I think so, maybe it was KGB. Yeah, welcome back, okay, so we're gonna have this thing here. Okay, and the trainer is gonna have this kind of stuff. So we're going to extract this to the trainer, and this is going to be a separate executable. So we have two separate executables for all of that. All right, and on top of that, I think we're going to first try to init game first. Like we do init game first. Oh yeah, by the way, reset player in FFZ is actually amazing. I absolutely love that feature of FFZ. So I don't think we need that thing anymore. So the idea is going to be, we're going to have like a command line arguments for all of that. And the entire thing is going to just load them. Okay, so we're going to have GP trainer and GP simulator, right? So GP trainer and GP simulator, and these are different executables, right? So, and we have to build them correspondingly. So this one is going to be GP trainer, GP simulator. Yeah, the first one is to just train some things. The second one is to see the results of the training. And I think it kind of does make sense. Okay, let's go to the makefile. And what we want to build here is we want to build all, essentially, GP trainer and GP simulator. So, and these are going to be separate targets. There we go. Welcome back, FIFO. Welcome to the stream. So GP trainer depends on SRC GP trainer C, and I suppose it also depends on game and visual part. Game and visual part. I think so. So the game and visual. Yeah. So it's gonna be SRC. GP game H. GP. Let's actually do it like something like common SRC. Right, so this is a common SRC, something that is shared between all the executables. And that common SRC is essentially GP game H, GP game C, GP game visual H, and visual C. So like a visual C++, right? And what we're doing here, what is LM? It's a math library. So in Linux, quite often, math library is a separate library that you have to link to if you have such functions. If you want to have such functions as sine, cosine, like anything from math.h. It's not a thing. It's not really a thing on Windows, but on Linux you really have to do that. Right, there we go. So similarly for the simulator, Tainer. It's not a Tainer, right? Simulator. There we go. So these are the things that we want to build here. Now let's see how they're gonna build. Shouldn't be the flag inside of the string. No, this is not a string, by the way. Backticks in shell mean different thing. So this is a shell command, and backticks mean that they will take the shell command, execute it, and they will put the output of that command as the value here. They will just copy paste the output here. So essentially what I'm doing here, I'm just calling this function, right? And I want this backtick string to replace with this kind of stuff. Learn about like backticks and shell. So it's like, yeah, it's the basics of shell. It's the basics of shell. All right, so let's try to build all that stuff and see if it's gonna work correctly. So no rule for game HP. And this is because you have to prefix all of them with src. Right, you have to prefix all of that with src. All right. So, and I also have to do similarly simulator. So I need 2 games here as well. Yeah, there we go. Dump file, and then we're dumping the file. Okay. So I think we need to provide the output file as an argument for this executable. So, and that's exactly what I'm going to try to do. So this is the current. Okay, so the current is going to go here. If RGC is less than 2, if it's less than 2, we're going to do fprintf std error. Error output file path is not provided. There we go. And we're going to exit with 1, and also we need to print the usage std error usage gp trainer, something like output bin. There we go. So maybe we'll also be able to customize amount of generations. Amount of generations. Yeah. So maybe we have to do something like this. Generations number. Generations count, right? So you will have to provide the output and the generations count, and maybe the first thing has to be the generations count, something like this. Yep. So I also want to implement like a pretty convenient function for parsing arguments. Yeah, similar to how I do that in AIDS in C++. So it's going to be a shift. And I'm gonna accept the pointer to RGC and maybe triple pointer to RGB, so I can automatically shift this kind of stuff. So, and yeah, if RGC, yeah, maybe it makes sense to assert this thing to be equal than 0, and essentially we're going to have a result, right? We're going to have a result which is something like this, right? And afterwards we're going to do RGC -1 and RGB +1. So, and then we'll be able to return the result. So I'm not sure if it's going to work correctly, but it may actually help triple pointer. I'm not sure if triple pointer actually makes... Am I a 3-star developer now? Am I a 3-star developer? Maybe. 3-star developer. Oh shit! I finally unlocked the achievement. I finally unlocked this achievement, I think. Shit. I don't know if it's ever gonna work, but we'll see. So essentially, the first thing I want to do, I want to skip this shit. I'm gonna skip this shit. Skip program name. Thank you for awarding me. And if oh shit, RGC equal than 0, that means yeah, we'll have to also have some sort of a usage. Pointer to two-dimensional array. Yeah, basically. It's a pointer to two-dimensional array. Hello, Viljanul, welcome to the stream. I recently became a 3-star developer, but it's not confirmed yet. It's not. We're still waiting verification, and after this code compiles, maybe I'll officially become a 3-star developer. We'll see. We'll see. So this one is going to stream generation count. So if this thing is not available, we'll have to say something like usage std error, then printf printf std error, no generations count, number of generations is not provided. Okay. And then I'll have to exit with 1. All right. So, and then we do shift RGC, RGV, and that thing I want to, in this case, I want to use A to I, right? And that gives me the generation, number of generations. So this is going to be generations count, like this. There we go. So afterwards, I want to check this thing again, right? Error, output, file path is not provided, and sure, output file path is going to be shift RGC, RGV, A to I. Did I say I to E? I to I. I'm sorry, I'm Russian bebega. All right, so output file path. Okay, generation count is not used because we have to use max count. Generation count. Oh shit, it actually worked. Well, I guess there we go. I'm officially a 3-star developer because it compiled, and I think it can even work now. So let me see if we can call this function, this program. So GP trainer. Okay, no number of generations is provided. Then I provide 69 of them, and no output file of output path, and I provide both of them, and it works. Okay, so my idea with the shift function actually worked. So this is actually pretty cool, cool function, as you can see. So essentially, it modifies RGC and RGV, and basically shifts the first argument to the left. So you basically consume the argument. It's kind of similar to how I do that in 8s, but in C, right? And to implement this kind of thing, I need triple star, like triple pointer, and it worked, surprisingly enough. Yeah, it's pretty cool. I'm proud of myself. And by the way, we're, generating these things. The achievement was hiding in the plain sight, exactly. It was hiding in the plain sight. So maybe we're gonna wait a little bit. It actually becomes faster over time. What about 5 stars? Is there like a 5-star? All right. No, a 5-star is not someone whose code contains 5 levels of indirection. Rather, a 5-star is someone who has reached the highest peak of programming craft, one who has reached programming enlightenment. But what's the criteria? 3-star level, someone who has learned to do 3-star programming and reveals into it. Someone who has learned how to do 3-star programming, but has also learned to not do it unless circumstances absolutely require it. Ah, I see. The Enlightenment. 5-way shield. You have to reach enlightenment, that's the criteria. I see. What's the enlightenment? Like, what is it? I don't know. We're gonna wait for 69 generations. So after 69 generations, maybe it will produce something interesting. Also, it's like single-threaded, but I'm not sure if I can easily parallelize all of that. If it's even parallelizable at all. Do type dev char str for funsies. Why? Okay. But it's not really a string, is it? Because it's a mutable string. So is that from some language? Isn't it supposed to be like const char? Oh, what's interesting is that if you call this a string, something with const could be a sister. Right? Makes sense. You can think of it as C-string or as a const string. Interesting. Thank you for suggesting that. I got enlightened. Now I'm a 5-star developer. Thank you so much. What if you run X simulations at once and then pick the best players? Maybe. And that will be parallelizable. They're not improving. They're definitely not improving. Nothing is improving here for sure. Yeah. Like they're just, I don't know. They don't know. But we're almost there. We just need to run 69 simulations. Maybe I have some sort of bug somewhere, I wonder. Gene pool too low. Maybe we need a higher gene pool. We can try to increase it at some point. So, but I do all of that just to test things out, because then I'll have to compile the simulator just to see the results. Unfortunately, you still have a long way to go before you become 10x developer. Yeah, I know. I know. But one day, maybe, I'll become 10xer. 69x developer when... Jesus Christ, I'm a child. Alright. So almost there. The generation 69 is here. Okay, so this is the generation 69. Now I need to fix my my compiling of the simulator. Yeah, so the simulator does not compile right now because we don't have dump file path. So we also need to parse command line arguments for this thing. So it's going to be usage file string. So we're going to do fprintf string gp simulator input bin. Now you have to wait another 69 years for a chance to become 69x developer. Yeah, that's true. Alright, so this is going to be the usage, and let's actually copy paste that shift thingy. I really like this like shift idea for some reason. I have no idea why. RGC, RGV, skip program name. If RGC equals 0, fprintf, actually first usage, std error, City error. Error. Input file path is not provided. And we're gonna do exit 1. Const char. Input file path. IID is amazing. I just saw it on one of the other chats, and I instantly thought that we need that emote here. It's absolutely amazing. I love it so much. All right. So, and here we're gonna do shift or GC or GV. There we go. And we have an input file path that we can use in here. Input file path. And by the way, I think we should not allow like regeneration here. That's for sure. I think I'm gonna disable all of these things here. For now, the only thing that will be allowed here is, to be fair, why not? Right. I know why. Let's disable it for now. All right. So let's try to compile that. GP trainer. So if I try it, it says that. But what about GP simulator? Oh, I forgot a new line somewhere. Simulator. I forgot the new line here. Classic. All right. So, and what I'm going to provide here, I'm going to provide GP simulator output bin. Okay, so here is the generations, the 69th generation. The 69th generation. Let's see if they're less bebega than the first generation. No, they're absolutely fucking bebega. That's for sure. They're absolutely fucking bebega. All right, that's pretty cool. I'm super happy that they're so bebega. Okay, at least we have tools for actually training more things and then checking their the results. Right, so we have a separate tools that can run several generations automatically, and then we can see the results with another tool. So this was the goal anyway. So Pepega Simulator. So let's go ahead and commit whatever we developed here. Maybe it would make sense to update README at some point, but yeah. So I'm gonna update a quick start. So GP trainer 69 output bin, and the next thing is gonna be GP simulator simulator output bin. So it's kind of important to update README because README is the first impression, right? So this is the first thing that people will see, and I think like it's important for these quick start instructions to be like relevant or up to date. So so we're gonna have a section called GP simulator, and the controls are actually related to the GP simulator. Right, so we have that, and we're gonna also have GP trainer, and it's not documented yet, so I'm going to put to be done here. To do GP trainer is not documented yet, so this is what we're going to put here. All right, split the whole application into trainer and simulator. Zoomer generation, yeah. So 69th generation is a Zoomer generation. All right. So what keyboard is that? It's a USB keyboard. All right. So this is my logo, by the way. For some reason, I'm so proud of this logo because the project generated the logo for itself, and it looks amazing. I don't know. At least I like how it looks like. It looks pretty cool. Okay, so we have this kind of thing, and yeah, there we go. I think I forgot to actually put a very important note, that if you change any of the parameters in the game, the game will become incompatible with the other parameters, but I don't think it's that important. It kind of looks like commit history. Well, yeah, I suppose. Have used Beekeeper 2, good choice. I know, thank you. So let's see. So maybe we should increase the gene pool. How about that? Selection pool. So we only have 10 of these things, and we have thousands of these Bebegas. We have thousands of these Bebegas, but we only pick 10 best of them. So I think maybe we should increase it, at least like take, you know, quarter of them. Maybe it would make more sense. So yeah, let's actually give it a try. So this is how we're gonna do that. I'm gonna rebuild everything. Best Bebegas and among Bebegas, yes. Alright, so let's start the simulation. You know what, maybe we should actually put the simulation to the make file. So let's call it train. Nah. So GP trainer, 69 generations. The output is going to be output bin, and let's just wait a little bit. There we go. 2 seconds. The next generation, 4 seconds. Okay. Second generation, still 4 seconds, and they're pretty much stable. Then it's going down over time. Release it on Steam as Pepega Simulator. Maybe I will. Alright, maybe it's increasing. Maybe there's a bug in the selection. Like, I'm afraid maybe I made a bug in the sorting algorithm or something. That shit dropped completely, yeah. Because that's what it feels like. It feels like maybe there's a bug in a certain algorithm. We can also try to increase the chance of mutation. We could make a really nice sprites for agents, food, walls, and greed and asset, right? And make a lot of money on Steam, right? So the agent should actually be the Pepega emote. I'm guessing trying to find a bug in genetic algorithm would be pretty hard. Yeah, I guess what you can do is just building hypotheses and just testing those hypotheses. And that's how you troubleshoot this kind of algorithms. No, 5 seconds. We don't really know what actually affects the performance. Well, I mean, the more like generations will probably affect the performance. Sub 5 second speedrun. Right. I found visualizing the process directly helps a lot. Yes, it does. Then Pepegas should turn into PHP. Yeah. Because maybe more like steps during the generation doesn't really affect the performance that much. So who knows? We need to explore that. 5 seconds, oh my god. And also there was a pretty cool suggestion to basically reduce the gene pool over time, right? At first you have a very big gene pool and then you increase it. Maybe you should try printing some stats for each generation, that might help as well. Yeah, I think so. So we need to come up with the stats. So the first stat that I remember people suggested. Okay, stats MD. Average lifetime, right? Average lifetime. Does any Can anybody suggest any other interesting stats that we can have? Genes merge together, it's not wise to mix them up. A 50 by 50 mating, it ruins adaptation. Cool, thank you. Does anybody have any median lifetime? Well, probably. Amount of food in the field. Yeah, amount of food after the run, after the generation. Yeah, kills, food taken. Yeah, feeding food in the field, max life, average, median, top percent. Amount of alive agents. We actually stop the generation when all of the agents die. So, distance traveled. Okay, distance traveled. Longest lifetime. Yeah, I think. Longest lifetime. So that's a good one. That's a good one. Distance traveled, long lifetime, creativity, uniqueness of the agent. How do you measure that? How do you measure creativity? Count of agents made it. Well, I mean, we're taking like agents at random. Ask them to draw something. It's a good one. After initial starvation wave. Yeah, shortest lifetime, longest, shortest. I don't know what is initial starvation wave. We don't have a formally defined initial starvation wave because it's an emergent property of the system. Like, it's kind of difficult to define it. Okay, so we actually have 69th generation and initial starvation wave. 100 divided by one food amount. Food amount of what? I don't understand you. I'm sorry. I think I'm begging. Simulator. So the output bin. And here is the 69th generation. Okay. And again, they just stuck. They do nothing. They literally do nothing. Alright. So, and then they die after some time. Okay, cool. By the way, why does it take so much time for a single generation? Because I literally can... I think I can do that faster. Maybe not. Yeah. Maybe it's around like for a second or something. Number of states used for the agent. It's actually hard-coded. The amount of states is hard-coded, so maybe we should increase it. I'll just try to increase it. So it's like there's 7 of them. Yeah. Alright, so I want to make a small break because I need to pee, and after I pee, we can try to implement all of these stats, right? We can try to implement all of these stats, and also try to tweak our parameters, our initial parameters, so they somehow change the stats, because right now the stats are not really changing. So, and I have a feeling that maybe this is because how we organize the genes, because genes is a state machine, right? So, and what is a state machine actually? Let me show you. So I feel like maybe with the state machine it just doesn't really work that well, because essentially you have a bunch of states, right? You have a bunch of states, and also something like this. So sometimes you may have like clusters of states in a state machine that are not reachable, and I'm not sure if mixing these things up is actually super helpful. Maybe we need to make sure, maybe we need to come up with an encoding that always makes like a connected graph of states. But that's weird, they do not try to move at any point. Yes, it is weird, so maybe we should try to inspect one of their state machines. Yeah, let's actually try to do that. Let's try to inspect one of their state machines. Okay, collect some stats. Right, so we're collecting some stats. Also, inspect chromosomes of agents. So we'll have to create a special tool. Why is the grid so large? Because there's a lot of cells there. All right, so inspect chromosomes of the agent. And I always have like this strange thought at the back of my mind. I want to check the sorting algorithm, because I feel like maybe I fucked up the sorting algorithm and I need to confirm that I didn't. I'm really sorry, I don't know what the fuck happened. Like, my internet just dropped down completely. I don't know how that happened. I actually had to restart my network, so I'm afraid that it might be something with my PC. I really hope it is not. So yeah. Yeah, KGB. It's definitely KGB. So let me make a small break, chat. Yeah. So, and after this, I'm gonna go on a break because I really need to pee. I'm really sorry. So let's make a small break and you guys have fun. Yo, welcome back. It was actually a little bit earlier than I expected, so yeah, let's continue. So I want to go through these things and just investigate what, how to fix all of that. So I have my doubts on the sorting algorithm. So let me see. QSort. We actually do that several times. So we have print best agents. I don't think this function is needed anymore, so I might as well actually go just remove all of that, hopefully. Yeah, so make minus b just to check if I didn't do a fakiwaki. Fakiwaki was not committed. Committed fakiwaki. I like this phrase. I don't know why. Somebody committed fakiwaki. I'm gonna remove that. I'm sorry, Aguduk. Wait, what? Do you see that? Oh, okay, so this is I thought you. Okay, I see. Starts working. I thought that was the answer of the bot. Hello, Adnan. Hello, welcome back. Yeah. So I thought for some reason my brain thought you pinged the bot and the bot answered starts working. I don't know why. Sorry, I think I'm getting tired. All right. So let's do commit remove dead code. Dead code. Welcome back, everyone. Alrighty, so let's find the QSort. The QSort. So how are we sorting everything? Essentially, the comparison function, if I remember correctly, QSort. Let's take a look. Compare. The content of the array is sorted in an ascending order according to a comparison function. Pointed by a compare, which is called with the two arguments. Okay, the comparison function must return an integer less than, equal to, or greater than 0 if the first argument is considered to be respectively less than, equal to, or greater the first argument. So that means we're essentially emulating a minus b situation, right? Because in that case, if this one is less than, this one is going to be negative. If they equal 0, blah blah blah. And that's why I actually reverted them. So instead of a minus b, I'm doing b minus a, and that kind of works. And let me try to actually check that. One way to remember whether you're doing ascending or descending sorting with A and B thing, I mean, I don't need to remember, I just derived the behavior myself, like I just don't need to remember that. Simulator, but thank you. So I'm gonna enable some of these things. Right, I'm going to enable some of these things. This one is going to generate a new thing. And when we do a next generation, I also need a mode where you don't necessarily have to provide any input file for this thing. Yes, I think that's what I need here. So I think the input file has to be optional. Because sometimes I just want to like start the simulator, and I want the simulator to come up with some random state, not the state that is loaded from input file. So I think I will have to change this behavior slightly. So skip the program name. If it's equal to 0, that means we don't really have any input here. So we'll also have to initialize this thing here. So I mean the random number generator. Okay, cool. So else we do it like that. But if it's not available, we'll have to do init game, right? Init game, and it's gonna be games. So it actually initializes like a random game. So, and I think I want to also log that. No input file, let's put warning. No input file is provided. Generating a new random state. So it's going to be like that. So, and here we're going to do something like this. Loading the state from here. Like this, and the state is going to be from input file path. From the input file path. There we go. So hopefully that will do the trick. And by the way, the current in that case must be defined somewhere here before everything else. Printf with slash, yeah, I see. And when we're dumping something, I think I'm gonna remove this action. This action is not really needed here. Section is not really needed here. Okay, so essentially I can do GP simulator just like that, and it will say warning, no input files provided, generating new state. So that's exactly what happened. The first state is even more like lively than. Yeah, so what if we optimize the amount of steps instead? Like amount of steps that they performed. Yeah, we can actually have several parameters. Did you simplify the logic, by the way? Yes, I did. So, game.h, and if I take a look at the amount of actions, we don't have eat and attack anymore. So it's only nothing, step, turn left, and turn right. So, yeah. It is in fact simplified. So, but now if I do something like simulate output bin, it actually loading it from my output bin, and this is the Pepega one. All right, it's the Pepega one. Maybe the fittest function in our case could be a combination of how long they survived, how many steps they made, how many food they eaten, and how many times they did an attack. So maybe we're optimizing the ones that can become very active, right? So, and yeah, committee. Yeah, I need to do a committee because this kind of like a fittest function will produce some interesting results. Don't you encode that in health? No, I don't. Health is health. I don't understand how I can encode that in health, but. Alright. Alright, so we're gonna do a committee. Make input file optional for GP simulator. And I'm gonna push that right into the repo. At the end of the round, health means how much food you ate. Like, I don't want to decode that information. I could probably decode all of that, but why do I need to do that? Be careful for local means, but we're not trying to optimize anything, we're trying to have fun. So, yeah. Okay. So what I was doing, stats. I checked the certain algorithm. So I also wanted to have like a tool that can inspect the chromosomes of the agents. Yeah, let's actually try to implement that. Is this like a sophisticated game of life? No. Check out project, check out playlist, all of the watch all of the previous parts, and yeah, then we can talk. All right. I provided all of the information necessary for you to get up to speed. So yeah, let's create like a special thing, like inspector. Yeah. So inspector. There we go. And SRC GP inspector. Will there be part 4? Looks like it. Looks like we're gonna have part 4 at some point. I'm not sure when, but it feels like we're gonna have it. Can you explain generally? Sure. Check out the project command and check out the playlist command. So we also have all the previous parts for you available. All right. So let's continue. It feels like I'm using Shift pretty much everywhere. So maybe I need to actually move that somewhere else. But I don't know how to call this thing. Alright, I'm gonna copy paste it anyway. So I need to come up with a name for the module where I'm gonna put a single function, and I cannot come up with it. aids.c, yeah, probably. Alright, so printf and usage is actually different depending on the executable. So usage has to be different. Usage has to be different. GP inspector. GP inspector, and I suppose we have to provide input bin. And I don't know exactly what we're gonna do. Maybe we can. I don't fucking know. Yeah, let's just provide input bin, and then we're gonna inspect all of that. So shift rgc rgv skip program name if rgc equal to 0, printf std error error. How is it called? No input file is provided. So usage std error, and then we have to exit with 1. Okay, thank you Ark Anya for the raid, and hello raiders, welcome to the stream. We're doing genetic programming, so yeah, check out this thing, and yeah, welcome. Welcome. So input file path, and what we're doing here, I need to load game. No. I'm doing shift rgc rgv. There we go. And then load game. How do I load the game? Game.h. Load game. Come on, load game. Much okay. Thank you for the raid. Thank you. So inspector. All right, and this is the input file path, and we'll have to provide the game. So one of the things I want to do here is just to look at the chromosomes of one of the agents. For example, we can just print the chromosomes. Print chromo, I think it's going to be std out, and I just take game agent c0 chromo, and of course we want to assert, like statically assert even, that agent's count in this case is greater than 0, otherwise we won't be able to do that. So I think I have to do it like that. So is it gonna compile simulator, and do we even build inspector? I don't think we do. Let's actually see. Okay, so Oh, okay. We need to have at least one agent to print anything. Okay. I did for 420 generations and they're still Pega. So I did a major fucky wacky somewhere, and I wonder what exactly we can do. Is this because of the way we describe their behavior? That could be it, actually. That could be it. So we have an inspector, GP inspector. Yep. And I'm gonna provide output bin. Don't you think it's kind of suspicious? I think it's kind of suspicious. The memcopy function doesn't look right in mate agents. Yeah. So we probably have a bug because this is suspicious as fuck. This is sus. This is straight up sus, chat. Now that's a definition of sus, which actually brings hope to my heart, because I was really disappointed and upset that maybe I'm so stupid that I cannot even come up with something working, but apparently it's just a bug. All right, so let's see what's going on. So what exactly not right here though? Memcopy in function doesn't look right. Exactly what? Because it kind of looks right to me. We can take a size of. Thank you so much. Size of. Oh shit. Oh shit. Okay. Oh my god, who suggested A0 frag? Dude, why are you bot though? Why are you bot? Oh my god, thank you so much. I'm gonna trust you. Are you either a frag or is there, I don't know, is there a frag bot? You're trusted, I love you. Thank you so much. Oh shit, Out9. We don't have enough slots. We don't have enough slots. Oh my god. I had such a huge anxiety during the stream that I won't be able to come up with something. But you helped me. What can we remove, by the way? I don't know, Huggers is not that much of a popular. I think like I like Dank Hug better. Remove force and CD. So let's actually remove Huggers because Dank Hug is like I like it better. So as a replacement we have Dank Hug, so we can use that one. So how do you remove that? We used a lot in the wholesome chat the other day. I don't know. Yeah, Pog. Nah. I never used it. Pog Omega. I think Pog Omega is not that often used. I don't know what to remove. Zoomer. Okay, Pog. Let's remove Pog. Remove from a channel. Bit too much. All right. Oh my god. Thank you so much. Thank you, EasyReflect. So, gene, size of gene. Maybe I also have to do it like that. Yeah, so it's the size of a gene. Does it compile? And also src game.h, and I also want to reduce the selection pool. Let's actually make it like 50. Weeb emotes decreasing. I haven't started watching anime yet. Maybe if I start doing that, the amount of Weeb emotes will be increased. Who knows? Who knows? Who knows? Oh, and by the way, this one... So we actually talk about, like, in terms of the bytes. Everything here is in terms of bytes. So this is correct, I think. Except, okay, this one is complicated because, yeah, we have to be super careful. This is in bytes, so that's why we do size of gene, right? But this one is not in bytes because it's like a pointer arithmetic. So it has to be something like this, size of gene. There we go. I think that now is... This code is correct. Chat, please tell me. Please tell me. Is this a correct code? I think it is. Right. Because this thing is typed, right? This thing is typed, so that means the pointer arithmetic is going to be correct. It compiles. Are you okay, streamer? You sound sad. I'm a little bit tired, and I got a little bit demotivated by the bug that didn't produce anything, and that's why I sound so sad. But I'm actually a little bit happy right now because we finally found a bug. Thank you so much for everyone who helped me with this kind of stuff, because oh my god, I was going crazy inside thinking that I'm such a pepega that I cannot produce even something interesting. All right. So, this should be working now. I want to recompile everything one more time, and let's try to do a simulation. P simulate, GP simulate, and we're gonna have 69 iterations, and the output being here. And let's see what's gonna happen. Maybe something interesting is gonna happen. Go! Could not open file 69. Really? What did we do? Loading state. Ah, trainer. Excuse me. Okay, 3 seconds. Alright, it increased a little bit. It's slowly increasing. Not really, not much, but... hopefully, maybe after that they're gonna become a little bit more interesting. Bless RNG, yes. Then it's decreasing. They're just fluctuating. Let's actually, you know, let's have like 10 generations. Alright, because we're testing whether we fixed the bug or not. So, yeah, let's just have 10 generations and maybe that will produce something interesting. Oh shit, it went to 4. And it kind of takes longer time, which hopefully means that they may be doing something. Okay, so they're done. I don't know what I was waiting for. GP inspector. So let's take a look at the GP inspector. And okay, this now doesn't look as sus anymore as before. So this looks like a legit thing. And what's interesting is that we start at zero state, and the first thing at 0 state, if you see food, you don't have to do actually anything, and you have to switch to 4, And at state 4, if you see food, you still have to do nothing but switch to state 3. And if at state 3 you see food, yeah, so it's a really interesting combination, but anyway, so after the 10th generation, let's take a look at what we have here. So it's going to be simulator, output. Oh my god, they're doing something. They're actually moving a lot. Look at that. They're doing things. Oh my god, Jesus fucking Christ, okay. And look at that, some of them survived longer. Oh shit, it's fucking working. Oh, thank you so much, everyone. Oh my god. I don't know what I would do without you, seriously, because sometimes I just get blind to the problems. It's such a simple, like, small problem that I did at the beginning of the stream. I introduced that bug at the beginning of the stream. Oh my god, thank you so much. So, 69 generations. 69 generations then. How about 69 of them? So let's do 69 and see how they're gonna perform. That's actually super cool. Maybe while they're performing, I may commit some of the stuff. Yeah. So I'm gonna do a separate commit for inspector. So here's the inspector and git ignore gp inspector. So introvert party while training. I don't know. We'll see. So git inspector, blah blah blah. So introduce gp inspector for inspecting dumps from gp trainer, right? And all right. Fix nasty mating bug. The fuck is this sentence? Alright. Increase selection pool. Alright, I'm gonna push that everything to the repo. Feel free to test it out. Is that an STD? Well, STD is actually, I mean, it's a virus, right? Is it not? No, STD is just it's a general thing. For some reason I thought about AIDS. AIDS is the virus, right? STD is just a category. Alright, so, cool. Sync, so we have 32nd generation. HIV is a virus, yeah. Oh, yeah. Because AIDS can be caused not only by HIV. That's why we have to separate the virus and the symptom, right? So there is a separately virus and there's separately symptoms. I think it makes sense. The time is slowly increasing. So I wonder what's gonna happen if like we have thousands of generations. Won't they consume all of the food? Yeah, sure. They will. Mem leak for the win. We don't have a memory leak. Even a single one. Trust me. We don't have a single allocation. Like, not a single allocation is done, like dynamic allocation in the whole source code. So, there's literally nothing to leak. Stack leak, yeah. Gene pool still too small, selection is too aggressive, but it's already better than we had before, so... Yeah, I do realize that it's not perfect, but it's my first time doing genetic programming, and I didn't read anything, any article about genetic programming, except the definition of genetic programming on Wikipedia. Cut me some slack, okay? I know it's not perfect, I just wanna, you know, discover things myself. You know, come on. Streamer flexing. I'm not really flexing, I'm just asking for a little bit of slack. Because it's kind of hard. Use every cookie. I don't eat sweet things. I don't eat sugar. Sorry. Alright, so I think we're getting closer to something interesting. 69th generation is actually getting very interesting. Do you have 99th chocolate? Yes, I do. Maybe I deserve like a chocolate, like a dark chocolate. Yeah, sure. You can even download the whole Slack application. Yeah. It's kind of cool that at the beginning it was like 2 seconds, but now it's like getting like slower and slower. And there we go. I think we finally did something. So simulation output bin, and let's see what they do. All of them are moving and doing things. Let's see who's gonna survive. All of them are doing things. Oh shit, they're eating food. They're actually, a lot of them are actually eating food. Well, I think it's a fucking success. I really like that. Okay, so I actually generated the next generation just to see what's gonna happen. You know, let's actually change the visualization. Let's change the visualization. Game, do they attack and drop food? Oh, by the way, I forgot to implement dropping food when they die. Shit. Would p-threads be hard to implement? I don't know. I never implemented p-threads. Cannibalism, yes, exactly. Oh, Annabot, hello. Welcome to the stream. Haven't seen you in a while. Well, I mean, since the recent stream. But yeah. You could use OpenMP. Yeah, for sure. And there's a lot of places where I could do make optimizations, because I actually use a lot of linear lookups in arrays. So the implementation is actually extremely fucking slow. I just, you know, hacked together some stuff. And yeah, I forgot what I was doing. Yeah, I wanted to change the rendering. So I have to go to Visual, Render, Game. Right. And I think I want to get rid of the dead things. Dead color. So essentially, yeah. Instead of color, we're always going to do agent alive color, right? And where do we call render agent? If agent, if game agents I health is greater than 0, only then we're trying to render them, otherwise they're dead. All right, makes sense. Makes sense. Compilation. So it's gonna do make minus b. Make minus b, and oh my god, this is so fucking fun, especially when it works. So alive color, we're gonna have dead color. We're gonna only have these things, so it's just an agent color. Just an agent color. Go. After this small project is done, after we have something more or less working, I'm definitely going to take a look at some of the existing articles about genetic programming and see what are the common approaches here. I just wanted to come up with something myself. Yeah. P simulator, not P, but GP simulator. Like, I look at this output and G is actually on the other line, and I think it's P simulator. My brain is so pepega. A PP simulator. Okay. All right. So now when they die, they're gonna actually disappear from the board. So there will be like a whole wave. Okay. Okay, and they're slowly dying. But a lot of them surviving at some point, so... I watched some videos a while back and they let it run for like 1 million iterations or more. Yeah, probably makes sense. Okay, so I think that's pretty good. So let me commit that. Don't render dead bodies. That's a nice commit message. Don't render dead bodies. Grab the lifetime. I haven't finished with what I wanted to do yet. Wait a second. Yeah, we need to add drop in food. Make agents drop food when they die. So we need to do that. Other agent health. Food in front of the agent. Okay. So if other agent is dead, it should spawn food on that place. But where that food is going to be located? Where that food is going to be located? So we need to find the cell in front of the agent. Yeah. So this is how we do that. So coordinate in front of the agent. And do we have an agent? Yeah. So there you go. And essentially, oh shit, we cannot really add a new food. All right, I think I have a better idea. Essentially, by killing an enemy, you also recover your hunger. All right, so that's going to be the solution here. So you also recover your hunger. Yeah, that's the easiest way to go here. Instantly. And maybe you also step forward because you managed to kill them, right? So you take their place. Because you need to eat them, so that's why you... Yeah, that makes sense. So you attack them, but if they're still alive, you don't move. But if you actually manage to kill them, like strike like the final blow, you will also increase your hunger, food recovery, and then step forward. I think it makes sense. All right, so let's try to recompile all of that, and let's try to run a couple of generations. Yeah, equal. Thank you so much, Thinner. Thank you. So, and that will actually force them to optimize to attack as well, because eventually they will run out of food, so they will have to attack each other. They will have to be forced to attack each other. Is it possible to visualize the training? It is possible, but I mean, it will take some time right now. So, because a lot of things like just take too much effort. I'm trying to come up with like super simple, quick solutions. Okay, so let's do training, and let's just train for maybe 10 generations, right? Just 10 generations and see what's gonna happen. The more options for food they have, the longer they survive, actually. So, and since they have each other as an option for the food, yeah, they will probably survive longer. And it keeps dropping. Okay. That's funny. So you think it's gonna be Pepegas? Yeah, it feels like they're gonna become Pepegas. GP simulator. Alright. Yeah, there's not that much of a Pepegas. Oh, thank you for the raid, Christian Power Part. And hello, raiders. Welcome. We're doing a little bit of genetic programming. Okay. Cool. So 10 generations were not as Pepega as I would expect them to be. So what's cool about simulation, you can press N and you can continue training from the moment you picked up. Seriously. So in this simulator, they all die, and you can press N and it will give you the next generation. This is actually pretty cool. So simulator can also act like a trainer if you want to. So that, yeah, and the next generation again. All right, so let's actually run for maybe 100 generations this time. I think, can we survive 100 generations? All right. What programming software is this? It's just a playground for genetic programming and stuff. You can check out the project commands, also the previous streams on the topic and stuff like that. 300 seconds. And 300 seconds is how many minutes is that? I think it's 5 minutes. Okay, let's wait 5 minutes. Does anyone have any questions, by the way? Do I need to commit anything? Yeah, I do need to commit something. Okay, make agents recover their hunger when they kill somebody. There we go. I'm gonna push that right into the room. What's your favorite virtual terminal emulator, if I may ask? I don't have any favorite virtual terminal. I just use whatever works for me. Like, I don't really focus on these kind of things. Right now I'm using EuroXVT, but that's because that's the one that worked for me. And yeah, so... Oh, would you look at that? They went up to 5 seconds. Oh shit. Thanks, you're welcome, I guess. I don't really like to focus on specific tools. I just pick something that works for me, and I just learn how to use it the most efficient way. 6 seconds. Oh shit. We need to implement like actually stopping generation on Control-C or something. What's the genetic programming? It's an optimizing solution by simulating nature. So you essentially generate a range of solutions, then you pick up the best ones and you mutate them a little bit, you actually cross over them, and then generate a new generation again. And you repeat that. So you basically optimize a problem by natural selection. Cannibalism is good, confirmed. Yes, yes. So they actually take... Look at that. We'll be able to... How about adding an ATA? The problem with adding any features right now is that I have to stop the simulation, and that means we'll have to start over again. So once we started this entire thing, I don't think we can easily stop it. So yeah. Let's wait. I think it's not gonna take that much, like 100 generations. Like, yeah. Absolutely agree. I never cared actually either until I was implementing one. So I was just curious what other people's priority are, but most seem to not have strong feelings to one or another. Yeah, I think so. Because terminal emulator is one of the things that you just forget about, right? So once you get used to a particular terminal emulator, you don't see it anymore. It like, you know, blends with your workflow. That's why I don't think people have any particular preferences and stuff like that. Do you always do crossover? In my Flappy AI project, I have a crossover odds variable that only does crossover only then. Otherwise, just copies the best one. I actually always do crossover. Basically, I take the pool, the selection pool, and I generate the next generation by randomly selecting the parents for the agents. So yeah. Like a wording, it just blends the work. Yeah, I also think so. Eugenics bad. Yeah, I also thought about it, Hamiko. I also thought about actually, I think I even said that like partially. We need to parse, you need to handle Control-C, and when you Control-C, it should save the last generation. So we're already halfway through. You can also do the, okay, yeah. But again, the problem with adding new features here is that I just have to stop. What file is bin? It's a binary file. It basically contains the state of the generation. It just contains the state of the generation. And it doesn't have any particular format. What I did, I just took the memory that contains the state of the generation and dumped that memory to the file system. So that's what I did. So it was just the easiest way to just save the current state. Hello, Fengchi. Welcome to the stream. We're training our Pepega agents. So we're aiming for 100 generations. What we're optimizing right now, we're optimizing their lifetime. And by the way, it's actually working. Everything so writes work. Not really. I mean, I wrote a thing that didn't work for quite some time and I needed help from the chat to figure out what the fuck is going on. So yeah. So it started at 3 seconds and it doesn't go down to 3 seconds. I wonder, like, probably after the stream, chat, probably after the stream, what I'm gonna try to do, I'm gonna try to have like thousands of generations and maybe leave it overnight and just look at what the algorithm came up with, and then we can take a look at the 5k generations or something like that. That'll be actually pretty interesting. 1,000 generations, yeah. 1,000. Oh shit, they degrading. They're actually degrading. God damn it. We're gonna get a Pepega generation. Maybe like every generation we should probably save it. Numpia, does T 100% in the bottom means something useful or just meme? It's just a meme, but also it's a temperature of the CPU. I know that it's hot. I know. I'm using laptop and I'm streaming from the laptop. I know it's very bad. Well, I just don't have any other laptop. I actually have another laptop, but it's also actually heats up like that. So I don't know. I don't have a desktop. I'm sorry. Don't have a desktop. So almost there. They're turning into humans, you think? Oh, because they become more Pepega. In such situation, consistency would be extra useful just to add a high number and stop in the morning. Yeah, I think implementing like a Control-C support would be very useful. And also continue training from a particular generation. Because, yeah, the GP trainer should also accept the state from which to continue. Yes, I think that would be useful. Yeah. And also maybe during the training we should save each individual state. Maybe we should save each individual just to then go back and check. Focus on graphics, Nick. Yeah. We'll see. What's the population size? I think 2,000. After it's done, we can actually simulate the game and see how they behave. So we probably will need to have the fourth part where we do graphing and stuff like that. Because this is actually fascinating, my god. And I'm surprised that my stupid idea with encoding the genes actually worked. I didn't expect it to work. But it fucking worked. It straight up fucking worked. We're almost there. This is the 100th generation. Alright, there we go. So, and let's take a look at what we got. Simulator, output bin. Okay, here they are. All of them are moving. All of them are probably killing each other. So it's funny how, you see how they like group in bundles. because they are currently attacking each other. That's actually so cool. So they're trying to like bundle so they can attack each other and kill each other for food. But yeah, it's pretty cool. For your information, chat, for your information, the first generation looks like this. This was the first generation. So just for comparison, this is the first generation. They literally do nothing or spin around. Okay, they're absolutely fucking dumb. And this is 100th generation. This is 100th generation. They're actually bundling in groups because they want to attack each other. Because when they kill somebody, that gives them the food. So this is the 100th generation. Which is already better, and it's interesting how they extinct more smoothly, right? The first generation extincts instantly because they don't fucking know what to do. And yeah, over time they die out. So I'm fucking surprised that such a simple idea actually works and produces something, and this is only 100th generation. So yeah. That's actually super cool. Look at this like bundles together. Oh my god, this is so cool. I also want to inspect one of their genes. So let's take a look. Inspector. There we go. So this is a state machine that we're optimizing essentially. So their behavior is encoded with the state machine. So they start with the state 0. So in a state 0, if they see agent, they step forward exactly because that's what they have to do. In a state 0, if they see food, well, this one specifically turns left because that one is not that good. If in state 0 they see nothing, they do nothing. Okay. But what's interesting is that they still. Oh, this is actually pretty cool. If in step 0 they see agent, they step forward and stay in state 0. So they learned how to attack in a loop. So this particular gene actually is responsible for staying in front of the agent and attacking them in a loop, and they learned that themselves. That's what's cool about it. Like we didn't code that explicitly, but they learned that implicitly through the rules. So that's actually pretty cool. Yeah. 2. Also, I'm gonna keep the stats and stuff like that. Anyway, so the source code of this entire thing is available here if anyone is interested in reproducing all of that. So I think I want to also add a couple of to-dos specifically for simulator. For trainer, I mean. SOC trainer. So what kind of to-dos we're gonna add here? The to-do is gonna be handle control plus C, continue training from the provided dump file. Okay, thank you. What's the name of the genetic algorithm we're using? I have no idea. I just came up with something. All right. Rest or additional work for GP trainer. Right. Cool. All right. So today's stream was actually super interesting. Yeah. So we finally implemented the actual genetic algorithm. What DS did you use? What is DS? I don't know what is DS, I'm sorry. I know nothing about genetics algorithm, I'm sorry, data structure. Arrays. I'm not even joking, I've just used arrays. Right, so today's stream was interesting, and here is the result of the stream. We managed to come up with a less Pepega generation that is actually fighting for survival. They're fighting with each other. And doing things. and trying to survive for as long as possible. And that is super cool. Yeah, that is super cool. So here's the result of today's stream. Here's the result of today's stream. Check out the source code if you want to reproduce all of that on your machine. All of that is written in C using SDL. And unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you, guess when? Guess when I'm gonna see you? According to the schedule, I'm gonna see you all tomorrow. Tomorrow we're gonna do a Rust programming. We're gonna do a Rust programming, and we're gonna continue developing our TUI framework. We're developing a UI framework for console applications, so we can use that in our application. So, and we do that in Rust. If you're interested in Rust and UI frameworks and stuff like that, feel free to join, because we're making our own framework. So, and also check out the schedule page for more information on different projects we're working on. Also check out our VODs YouTube channel, where we archive all of the VODs. This VOD is going to be available there later on the next day, and I also maintain the playlist related to genetic programming. So all of the genetic programming streams are going to be in that playlist, so you can binge watch them if you're interested in them. And also we're definitely going to have a part 4 at some point. I'm not sure when, maybe on Friday, because I really want to continue, like, make more graphs and stuff like that, like gather more stats and everything. And also check out our Discord server for offline discussion with the community. And yeah, let's maybe raid somebody. We got raided several times today, so maybe the time has come to raid somebody else. Is anyone streaming anything super interesting today, chat? Do you guys have any suggestions? So we have begin bot. Nothing left behind. Raid yourself. Go raid yourself. So we have Nibbles.io and we have begin bot, but do we have anyone who's doing like artificial intelligence or machine learning or something like that? Oh my god. Twitch is slow. Twitch is super slow. CSS Grid. CSS Grid. Okay. Everything interesting is not in English, unfortunately. Alright, boys and girls, I don't see anything, I'm sorry, I tried. Thanks everyone for watching, and I see you all tomorrow. Love you all. Bye.